Hi, in this section we will learn about the following: why there is a need for structures and unions, introduction to structures and unions, then we will see what exactly a structure and what is a union. Let us start with first why there is a need for structures and unions. Consider the following array A with 5 elements. There are some advantages and disadvantages of using array. Among advantages part, the accessibility of elements are fast. We want to perform any operation on array, it will be much faster because accessibility is with respect to either index or with respect to address. The major disadvantage of using array here is, one of the restrictions of using array is the array should contain elements of the same data type. Obviously, array contains all the elements of similar type only. If I am creating an array of integer, that means that all the elements in the array should be of integer type. Otherwise, if I want to create elements of float type, then all the elements should be of float type. Similarly, character type, similarly any other data type. Situation arises where we want to store some data elements of integer type, some data elements of character type, some data elements of float type. Then we can go for the data types like structures and unions. Let us see here. We have already came across the data types in C language and covered the primary data types: char, float, int, void, and among the derived data types we have covered with pointers, arrays. Now, the other derived data types are structures and unions. We still have user defined data types, that is enum and typedef. For that, we will have a separate video covering enumeration data type and typedef. But here, let us start with structures and unions. So they fall under the category of derived data types. A structure and union are the derived data types in C language. A structure creates a data type that can be used to group items of possibly different types into a single type, or using a single name we can place multiple data elements of different data types. Similar to structures, C provides another derived data type with a little difference named as union. There is a small difference in the memory allocation and memory access with structures and unions. When we come for the difference, we will see what exactly the difference is. Now let us see what is a structure is. A structure is a derived data type in C language and is referred with a keyword struct. There are 32 keywords C language supports. Among them, one is struct. We want to create a structure, then we should use a keyword called as struct. Now, a struct is a heterogeneous in that it can be collection of data of different types, whereas an array, if you see, it contains homogeneous set of elements, that is, it contains the data elements of similar data type, whereas a structure on the other hand contains data elements which we can say collection of heterogeneous data elements. Same way, a union is also a derived data type and is referred in your program using a keyword called as union, or we want to create a union, we should use a keyword union. We will see the syntax of both structure and union in the next video. Same way, a union is also heterogeneous, that is collection of data elements of different data types similar to structure with a small difference. That's all regarding the introduction part of structures and unions. In the next video, we will see the details of these two derived data types, that is structures as well as unions, in detail, how to declare it, how to assign the values, how to access the values, and with a simple demonstration program, we will see the working as well. For time being, that's all for now. We will see the remaining topics in the coming videos. Thank you. Hi. In this section, we will look at the following. What is a structure? Some basic concepts of structures. What is the syntax for declaring a structure? Then some examples using structures. How to declare a structure variable, and how do we access the members? We call it as data members of a structure. And how do we assign a structure to another structure? And at the end, we will look at a program to demonstrate structures in C language. Let's begin with understanding what exactly a structure is. We have already covered in the introduction part of structures and unions in a separate video why there is a need for structure. As we know that array contains homogeneous set of elements, that is all the elements of the similar type, whereas some situation arises where we need to place multiple data elements of different data types. We call it as heterogeneous types. Then comes structures into picture. A structure is a collection of related data items, possibly of different types. The purpose of having a structure is to place multiple data elements of different types together with a single name. We call it as a structure. A structure is a derived data type in C language and is referred with a keyword struct. That means that whenever we want to create a structure, we should use a keyword struct, and structure falls under category of derived data type, as data types in C language are classified into three categories: primary data type, user defined data types, and derived data type. In primary data type, we have char, int, float, void. In user defined data type, we have enum and typedef. And in the category of derived data types, we have pointers, arrays, structures, and unions. So structure falls under the category of derived data types. A structure is heterogeneous. That means that it is a collection of different data types, whereas array is a homogeneous one, since it contains all the data elements of the similar data type. Let us start here. Some basics of structures. Structures hold together the data elements that belongs to it using a name. We call it as a object. Example, let us take some real-time structures. We want to place the information of a student together. Like student information consists of student ID, name, major, gender, year of admission or the starting year, and so on. Say a customer in a bank with the following details: account number, name, currency, balance, branch, and so on. Address details: name, house number, street, city, locality, pin code, and so on. Now, these information, if we closely observe each example, let us start with student over here. Student information consists of here student ID. Let us assume that student ID is of integer type. And name, as we know that name is a character array or a string. So here we must have a character array for storing the name of a student, whereas student ID is of integer type. Similarly, we have major, gender and start year, which stores different data elements for which we must have different data types. So structure provides the flexibility of providing multiple data types into a single name. Similarly, bank account number is of say long int, name is again character array, and so on. Different data types it consists of. So collection of these heterogeneous data elements together in the form of one name, we call it as a structure. In database applications, these structures are referred as records. Now, individual components, we call it as data elements of a structure, are called as members or fields. The same concept is taken in C++ in the form of a class, and these components and data elements forms data members over there. The concept of C++ class came from this concept of structures. Members can be of different types. They can be simple data elements, or they can be array, or they can be again structures. A structure is named as a whole, while individual members are named using field identifiers. We will see this one with an example. That means that a structure will have a name, total set of elements will be accessed using one single name, whereas each individual data member is identified using a field identifier. Complex structures can be formed by describing arrays of structures. That means that if we have some complex structures, example, records of students in a college. Say for example, we have multiple set of students records are to be fetched and are to be stored. Then we must go for arrays of structures. This topic we will cover in a separate video. Let us see now the syntax to declare a structure. A structure is declared using a keyword called as struct, followed by structure type, also called as structure name. Then flower braces is must, followed by the data type and identifier list. Every identifier will be terminated with a semicolon, then followed by another type, another identifier, and so on. At the end, we have closing flower braces followed by semicolon. This semicolon specifies the end of a structure declaration. Each identifier defines a member of the structure. We can have multiple members with different data types. Example, date, a structure with a name date having 3 data members over here. Day is of integer type, month is of integer type, and year is of integer type. The date structure has 3 members. Let us see some more examples here. Say for example, student information, student ID, the age of the student, both are of integer type, gender then is of character type, CGA is of double. So here the student information structure has 4 members of different types. Another example, student grade. In this example, if we closely observe, all the members are of the type array. That means an array is a data member in a structure. The student grade structure has 5 members of different array types. First one is a character array, second one is also a character array, and the remaining 3 are integer arrays. One more example with bank details. Customer name is a string or character array. Account number, if it is more than 10 digits or more than that, we can go for long also. Double balance. Now here if we see carefully, birthday is of type what? Not integer, not float, not char, nor double, but it is of date type. What is a date? Date we have already just now seen. Here is date consists of 3 things: day, month and year. So a customer birthday consists of day, month and year. So instead of giving 3 different things separately, we have already created a structure with a name date, and now we are creating an identifier with a name birthday of type date. So here this one is a very special one. The bank account structure has simple array and structure types as members. This is another category of example. Let's see one more here. Student record. The student record structure has 4 members: character array, integer, character array and a single character. Let's now see how to declare a structure variable. Declaration of a structure variable is structure type followed by identifier list, then followed by semicolon. Example, student record, we have already seen a structure name with student record followed by student1 comma student2. When we create this type of variables, this is something referred to be as declaring a structure variable or creating object for those structures with a name called as student record. So there are 2 variables or 2 objects. Whenever we declare it like this, in the memory it will be something like this. Student1 consists of name, ID, gender and department. Similarly, student2 will also have a separate name, ID, gender and department. Student1 and student2 are the variables of student record type, are also called as objects. Let us see how do we access the data elements of a structure. We have a special operator called as dot operator to access the members of a structure type variable. Here is structure variable dot member name. Example, we have a structure with a name called as student1. If at all we use it something like this: student1 dot name. Name is a character array. We are now assigning some name Mary to the student1 name. We are assigning the name Mary to the character array and ID, student ID. Now here the most important thing is we are accessing, how we are accessing it, using a dot operator. Student1 dot name, student1 dot ID, student1 dot department, student1 dot gender is assigned some values over here. Whenever we assign it a value in the memory location, it will be something like this. Then we want to print or display the data to the user. We can use it printf statements or put string for printing the strings. Let us see now how do we assign the values or data elements of a structure to another structure. The values contained in one structure type variable can be assigned to another variable of the same structure type. Since student1 and student2 are the variables of the same structure, we can assign it something like here. Student2 assigns student1. Contents of student1 will be copied into student2. Since student2 also is of the same type, the data elements are just copied into the memory location pointed by student2. In this example, we have student1.name first assigned with some name, student1.id is assigned with some id, and student1.department is assigned with some value. Lastly, gender is assigned female, that is F. All these 4 values are copied together into student2 with this particular assignment, student2 is equals to student1. Hope the concept of structure and the basics of structures are clear. We will see a program in the next video. Thank you. Hi, let us see now a program to demonstrate the working of a structure in C language. As we have seen in the last video, the basics of a structure, that is what is a structure, how to declare a structure, how to access the elements of a structure. Now in this program we will see how to declare a structure, how to declare a structure variable, and how to access the data members of a structure. Here we are declaring a structure with a syntax. The keyword struct is used, followed by structure name is employee, and the data members are the data elements, and the data elements of a structure are employee ID is of integer type, name of employee is a string or character array, age is of integer type, and salary is of long type. Here we are creating a variable of type employee. We says that this one E is a structure variable, also called as an object. Using this object E, we can access these data elements. How? Let us see it over here. Giving a message to the user to enter the employee ID, and we are reading the first one something like this. E.id, dot operator is used to read and write. Same way, E.name, E.age, and E.salary. Whatever information we are entering it through keyboard, the same information we are displaying it here. So a very simple program to demonstrate how exactly a structure is declared. Here it is, and how a variable is declared, and how they are accessed using dot operator. Let us build and run this. Enter employee ID, say employee ID is 100, name of an employee, say Mary, age, and salary. Same information what we have read, we are displaying it over here. I'll repeat once again. This program is meant for demonstrating how to declare a structure, how to declare a structure variable, also called as an object, and how to access the members of a structure using dot operator. Here we are first reading all the data elements and displaying the information again using the printf statements. Okay, hope the concept of structure is clear. We will have more programs on structure in the coming videos. So the remaining topics we will continue in the coming videos. Thank you. Hi. In this section, we will learn about the following. First, we will start with understanding what exactly a nested structure is. Then, we will look at the syntax for nested structures. then an example program for nested structures, and the execution of the same program. Let us begin with what exactly a nested structure is. C provides the feature of nesting one structure within another structure. Like there is a concept of nested if, nested for, nested while. So nested conditional statement, nested looping structures. Similar to that, we have nested structures as well. That means that we can provide a structure within another structure. Where exactly this situation arises? Where we have complex data type to be defined, then we can go for a nested structure. Example, we may need to store the address of an employee in a structure. Address itself is containing multiple data elements like street number, house number, city, locality, pin code, etc. Whereas in employee structure, it is just a part. So we can have a nested structure in an employee structure as address. The attribute address may also have the subparts as street number, city, state, and pin code. Hence, to store the address of the employee, we need to store the address of the employee into a separate structure and then nest the structure address into the structure of employee. We will look at this one with an example, but before that, we will have a syntax. So one structure which is independently defined with a keyword struct name structure1, and second structure is now having the object to be created for the first structure over here. So structure 2 is now having structure 1 within structure 2. So one structure is nesting another structure over here. Let us consider the example over here. Say just now discussed example, say address. Address consists of house number, city, pin code, locality, province, etc. But here we are considering only 3 fields: house number, city, and pin code. Let us have employee structure here. Employee structure consists of employee ID, employee name, and salary, followed by the address of the employee. The address itself consists of multiple fields. In this particular scenario, we can create a separate structure for address and then nest this structure within employee. So this line struct address add creates the object of address structure. Then there comes a question: how do we access the data elements of employee structure and how do we access the data elements of address structure? Let us have a look over here. The object of address structure is created in employee structure and the object of employee is created in main function. We can even create this structure object E for employee structure before main function as well. That will become global object. Now we are reading the details of employee structure as object name E dot member, that is E dot ID first, then E dot name, then E dot salary. Then to access the data elements of address structure, we have to follow the syntax. E dot add, that is the object of address structure, dot followed by the data element of address. Same way, E dot, that is E is the object of employee structure, dot add, that is the object of address structure, and dot followed by data element. Therefore it is E dot add dot house number, E dot add dot city, E dot add dot pin code. these three fields belongs to address, so they cannot be directly accessible. They have to access through the object of address structure. Same way, whatever data we have read, we are trying to print the data here using printf statement. The details of employees are as follows: e.id, e.name and e.salary, that is direct access to the data elements of employee structure, whereas these three, house number, city and pin code, can be accessed e.add.housenumber, e.add.city and e.add.pin code. This is how we access the data elements of nested structures. Let us see the execution of the same program what we have just now seen. Same program, address structure first. Here we have address structure defined with three data elements: house number, character array, that is a string, again city is also a string, pin code is also a string, whereas employee detail consists of employee ID of integer type, employee name is of string type, salary is of float type and address is of type structure. So we will create an object over here, which structure is already defined over here. We are reading the contents over here and trying to display the data using these printf statements. Let us build and run. Enter the data. Say salary, house number, city, say Los Angeles, with the following pin code. Here is the details: employee ID, same details whatever we have read over here, e.id, that is 100, e.name, that is here, salary, e.salary, and you can see house number. House number is read through e.a.house number, and similarly it is printed also using e.add, that is object of address structure, followed by house number. So this is how we can access the data elements of direct structures and nested structures. Hope the concept is clear. We will see the remaining programs in the coming videos. Thank you. Hi and welcome to the practice program. Here we will be demonstrating the working of nested structures in C language. A structure is said to be a nested structure if the data members of one structure is required within another structure. Say for example, here if I have the details of employee, what would be the details of employee will be? Here we have employee name, department, employee ID, salary. Then when we come for address, address itself contains multiple data elements. That's why we have created a separate structure for address, in which house number is one data element, city is another data element, pin code, then followed by street. So such sort of data is to be stored. Say employee, we have ID of the employee, name of the employee, the department in which he is working, then followed by the salary. When it comes for address, this address is again nested over here. Now the only thing what we need to remember whenever we access the nested structure data elements, we will be having two variables over here. One variable for the main structure, another variable for the substructure, that is internal structure. Say for example, I'll be taking it as E for the main structure and A for the substructure. Then The data elements can be accessed in this particular way. If I want to access ID, then I can use directly e.id. I want to access name, I can directly use e.name because they are directly the members of this particular structure. Same way e.department and e.salary. But when it comes for accessing the data members of address, what are the data members of address we have is house number, then followed by city, then followed by pin code and street. When we want to access these data members, we cannot directly access using the variable name E or object name E. We have to access it using this substructure variable name or object. It will be something like this: E dot A dot house number. Same way E dot A dot city. Same way E dot A dot pin, and the last one is E dot A dot street. Using this particular concept, we will be seeing the working of this data. First, we will read the data elements, ID, name, department, salary, and all these things we will be reading, and then we will be displaying the data simultaneously. Let us see how this program works. Here is the employee structure, which contains name, department, employee ID and salary, whereas address contains internally one substructure over here, which is containing house number, city, pin, street. Structure employee is having one variable name and structure address is having another variable name. These variables E and A are also known as objects or structure variables. Using this, we can access the data elements of each structure. Here, the first printf is giving a message to the user to enter the ID of the employee. Since employee ID is a direct data member of EMP structure, we will be using the variable name or object name e.empid. Since it is an integer type, %d and ampersand is required. Same way, name is also a data member of employee structure, so e.name, but this is directly used without using ampersand over here. Here you can see there is no ampersand required since it is a string type. Same for department also, e.department, and for salary it is a float type. Now comes till here, the data what we have read is for main structure data, that is for employee structure data directly. But from here onwards, the address starts. This is the contents of address structure. How they can be accessible? They can be accessible using E, that is a main object of EMP structure. This is another object A of address structure. So we will be using e.a.house number. House number is the data member of address structure. Same way e.a.street and e.a.city. Wherever string is there, we are not using ampersand. Since pin code is of long type, %ld is used, and once we are done with reading of this particular data, then here onwards we are trying to display the data. So here till this particular part we have performed reading of data. Once we are done with reading of the data, here we are now going to print the data or display the data. How we are displaying it? Same information, e.empid, e.name, e.department, e.salary. But here onwards it is nested data elements. So e.a.house number, e.a.street, e.a.city, and the last one is e.a.pin code. Let us try to build and run the information and see what would be the output. Let us say employee ID is say 1919, name say some John, department say accounts department, some salary with house number, street number, city name and the pin code. Here this part of the contents are for reading the data into the structure, and this part of the contents are used for printing the data or displaying the data. Same thing, you can see employee ID 1919 is displayed here. The information John with accounts department and salary, house number, street number, city name and pin code. This is the information what we are printing it using normal structures as well as nested structures. Hope this particular program gives you a clear picture of how do we access the contents or the data members of a normal structure and how do we access the contents or data members of a nested structure. That's all for now. We will see the remaining topics in the coming videos. Thank you. Hi. In this section, we will learn about the following. First, we will see how exactly arrays and structures can be used together. Then, we will look at the syntax for declaring structure array or arrays of structure. Then, at the end, we will see a program to demonstrate the arrays of structures. Let us begin with understanding how arrays and structures are used together. As we know that structure is a collection of different or heterogeneous data types. That is, the data elements in a structure can be of heterogeneous type. An object of structure represents a single record in memory. And if we want more than one record of structure type, we have to create an array of structure or object. As we know, an array is a collection of similar type, that is homogeneous data elements. Therefore, an array can be of structure type. Let us see the syntax for declaring a structure array. Here is the normal declaration. What we have starts with struct keyword followed by structure name and multiple data elements of different data types. We can have variable 1, variable 2, so on up to n number of variables. Then here comes how we can create an array. Struct followed by the same structure name followed by space and object name followed by the array size. Let us have an example. A student structure consists of 3 subject marks, total, and the name of a student. Let us create such a structure for 50 students. So same information has to be repeated for a class of student with 50 strength. So I am creating an array of structure and the size over here is 50, and we are reading for just example purpose the records of 3 students. If you want, you can repeat the same for loop for 50. So in this for loop, every time a for loop executes, you will get a message, enter the name of a student, s of I, that is the objects. Now you can concentrate over here within this scanf statement, 3%d, 3 delimiter operators, that is format specifier because marks are of integer type, and how we are reading the marks over here, ampersand s of I, that is for the first time when I value is 0, s of 0 dot marks of 0, that is since marks is an array which consists of indexes 0, 1 and 2. Therefore, s of I dot marks of 0, s of I dot marks of 1 and s of I dot marks of 2. This will be the marks of the first student. Once you get this data, you can add those marks by saying s of I dot marks of 0 plus s of I dot marks of 1 and s of I dot marks of 2. That will be stored in the total of s of 0 dot total, that is the record of the first student. When I value gets incremented, then this will be the record for second student. Same information repeats now. S of 1 dot name, we are reading it. Then the information is going to be read as follows. s of 1 dot marks of 0, s of 1 dot marks of 1, s of 1 dot marks of 2. These 3 marks are the 3 subject marks of second student. Same, at the same time we are summing up the marks and storing into s of I dot total. Same thing is repeated for third student also. And if there are 50 students, it will be repeated for 50 students. We are displaying the same information: student details, name, marks, total, M1, M2, M3. Using /t, we are using 8 spaces, we are displaying it, and using this for loop 0 to 3, that is 3 records we have read, so we are displaying the information of 3 students. S of I dot name, that is s of 0 dot name, s of 0 dot marks of 0, s of 0 dot marks of 1, similarly s of 1 dot marks of 2, then followed by the total for that one. Same thing is repeated for 2 more students here. If it is 50 students, it will be repeated for 50. And the same program we will look as the execution part in the next video. So the remaining topic, that is the program execution, we will continue in the next video. Thank you. Hi, in this section we will learn about the following. What is a self-referential structure and what is the syntax used for declaring a self-referential structure? Then we will see an example using a self-referential structure. At the end, we will see what are the applications of a self-referential structure. Let us begin with understanding what exactly a self-referential structure is. Self-referential structures are those structures that have one or more pointers which points to the same type of structure as their members. There can be one single pointer or there can be multiple pointers within the structure member list which points to the same type of structure. In other words, structures pointing to the same type of structures are self-referential structures in nature. A structure can contain members that are pointers to the same structure. Let us see the syntax. How do we declare a self-referential structure? Struct is the keyword followed by structure name, includes member list with the type, and at the end we see over here a pointer variable of type the same structure in which it is defined. Now this pointer can be declared anywhere in the structure. It's not mandatory to have this pointer declaration at the end, but just to have a clarity, we used to declare a pointer variable of self-referential structure usually at the end of the members list. Let us have an example of a self-referential structure. Struct node consists of 2 data elements. One is data of integer type, another one is a pointer variable named as link, which is pointing to the type of a node of the same type, that is structure type. How do we read this statement is struct node asterisk link. Link is a pointer variable which keeps the address of the node in which it is declared, and node is a structure. So a link will be created to point it to the same type of structure. It is something like this. Diagrammatically, link is a pointer variable which is keeping the address of the same type of node, and this type of self-referential structures are very useful in implementing data structures like linked list, trees, graphs, and many more data structures which are represented using linked list data structure. And at the end of this section, we will see now what are the applications of self-referential structures. Most commonly used self-referential structures are in linked list. There are many types of linked lists are there. Like if a structure contains a single pointer, it is called as a singly linked list. If a structure contains two pointers, it is called as doubly linked list. And circular linked list is one among them, where the last node always keeps the address of the first node in the linked list. We call it as a circular linked list. Tree traversals. We have in-order traversal, pre-order traversal, post-order traversal, and level order traversal of a tree. Binary search tree operations. When we want to insert a node or perform a search operation on a binary search tree, then also the node structure will be of the form self-referential structure. Polynomial manipulation is another operation where self-referential structures are used. There are many applications of self-referential structures and we have listed some among them. That's all regarding self-referential structures in C language. That's all regarding self-referential structures in C language. We will see the remaining topics in the coming videos. Thank you. Hi, in this section we will learn about the following. First, let us see how many number of ways are there in which the data elements of a structure can be accessed. Then we will have an example program to access these elements of structures using pointers. And at the end, we will look at a mechanism using which we can allocate the memory at runtime. We call it as dynamic memory allocation. Let us begin with understanding how many number of ways are there in which the data elements of a structure can be accessed. The data elements of a structure can be accessed in two possible ways in a C program. First one, using normal structure variable. We use it a dot operator, that is structure variable name dot data element. We usually call this structure variable as an object. So we call object name dot element. And the second way of accessing the data elements is by using a pointer variable. Whenever we use a pointer variable, then we must have arrow operator to use. That is pointer variable with arrow operator followed by the data element. Let us have an example program to understand how exactly pointers can be used to access the structure elements. First, we have an example structure over here with a name person with two data elements, age and weight. Age is of integer type, weight is of float type. At line number 9, we are creating a pointer variable which stores the address of a structure with a name person, and we are creating a structure variable as well. Now this pointer variable person ptr is now taking the address of person 1. Using this pointer, we can read the data elements as follows. First one, ampersand person ptr arrow age, person ptr arrow weight. Same data is displayed using arrow operator as follows. Age is displayed first, person ptr arrow age, then person ptr arrow weight. At the end of this section, let us see what exactly we mean by dynamic memory allocation. Some situation comes where the number of structure variables used in a program may not be sufficient. That means at compilation time, it may not be decided how many number of objects we have to create. Then at that time, we may need to allocate the memory during runtime. See, there are two phases for a program execution. One is compilation time, another one is runtime, which is also called as execution time. Structure variables, whatever we declare it, will be allocated the memory at compilation time. So if there is not sufficient variables declared, then in this situation we can allocate the memory at execution time, that is runtime. Here is how we can achieve this one in C program, that is using dynamic memory allocation functions. One among them is malloc. There is a separate video discussing about dynamic memory allocation. There we have seen the functions malloc, calloc, realloc and free. Here in this section we will have an example to understand how dynamic memory allocation takes place for structures. Here is a structure with a name called as person with 3 data elements. One is age of integer type, another one weight which is of float type, and name is a string or character array. Here is a pointer variable which is keeping the address of a structure person. Now let us allocate the memory for n number of such structures with a name person. Here malloc function is using one parameter n multiplied by the size of operator is used to calculate the size of the memory occupied by the data elements of a structure person. In case we know that the environment is going to occupy the memory, then we can allocate the memory and specify the size instead of using size of operator. For example, if we know integer occupy 4 bytes, float occupy 8 bytes and character occupies 1 byte. So in our case over here, age takes 4 bytes, weight 8 bytes and name 30 bytes. So it's going to be total of 42 bytes of memory. That 42 multiplied by n is now going to be allocated the memory at runtime. But if we are not sure about the environment in which we are working with and not sure about the size of the data, then we can use size of operator which calculates the size in number of bytes, then multiplied by n, malloc function will allocate the memory at runtime. Here we are typecasting this one because malloc returns a void pointer and ptr is a pointer of person which is a structure. So before assigning the address into ptr, we must typecast it in this way using parenthesis struct person star. That's all regarding structures and pointers in C language. We will see the remaining topics in the coming videos. Thank you. Hi. In this section, we will look at the following: structures and functions together. When we pass parameters to a function, how structures can be passed as parameters. The first topic will be passing structures as parameters to the functions, and how individual elements of structures are passed as parameters. Then how structures are passed as value arguments, something referred to be as call by value, and at the end call by reference, that is pointers to structures as function parameters or function arguments. When structures are passed as parameters to functions, C allows a programmer to pass the structures in 3 possible ways. That is, First one is we can pass single data elements or entire structure information to or from a function. There are three possible ways of passing parameters. First one is this one, a single data element, you can pass it. Second one is entire structure can be classified into two categories again, that is pass by value and pass by reference. A structure information can be passed as a function argument. Now, the structure variable may be passed as a value or reference. These are the two categories of passing the structure as arguments as a whole. If structures are passed as value, that is first mechanism, call by value, then function will return the value by using the return statement. If at all there is a return value, that is we want to return a structure, then we can return it using a return statement. Then the return type will be structure return type. Let us see the first category, how we can pass individual elements of structures as function arguments. In this method, each data member of a structure is passed as actual argument or actual parameter when the function is invoked or there is a function call. The actual arguments are then treated independently as ordinary variables. That is, the values of actual arguments or parameters are substituted into the formal parameters as the normal variables, and whatever we process with normal variables, we can do it with these data elements of a structure. This is the first category of passing individual elements of structures as function arguments. Let us see an example of passing individual data elements of a structure as function arguments. Consider a structure named person with two data members, age of integer type, weight is of float type. Declaring a structure variable with a name P is also called as the object of a structure person. Then in main function, when we call the function display, we can pass these individual data elements age and float as follows. P.age, P is the variable of a structure, also called as the object. So dot operator is used here with P.age and P.weight. In function display definition, it is implemented something like this. P.age value is substituted into a variable a, which is treated as a ordinary variable, and P.weight is substituted into a variable w, which is treated as a normal variable. So whatever value is assigned or read in P.age, that is the data member of structure, and P.weight, that is now copied into a and w, and that can be accessed in display function as a normal or ordinary variables. This is the first way of passing individual data elements. Here is the second one, entire structure, we are passing it as arguments. When there is an option of passing entire structure as arguments, then there are two possibilities. One is call by value, another one is call by reference. This example, now we are seeing it value arguments, that is call by value. Consider a structure student with character array name, integer age. Say display function prototype specifies void return type and parameter structure with student name, and s is the structure variable. Now in main function, we are creating an object s1 of student structure, and first we are reading s1.name and s1.age. Once we got the data for both the data elements of structure, then when the function display is called in main function, we are passing now the entire structure as a value argument. With this function call, this display is called, and the values of S1, that is name and age, are now copied into an object S. There is a separate memory location for S1 with name and age, and there is a separate memory location for object S with name and age. So the values over here will be copied. That's why we are saying this one as a value arguments. Whatever change we do it in display function over here for s.name and s.age, that will not reflected back into the structure contents. For more detail and explanation on call by value and call by reference, there is a separate video with a title called as call by value and call by reference in function chapter. You can refer that. This one is the third category when we pass structures as pointers. Now you can look at over here into the left box where create date 1 takes 3 parameters, month, day and year. We are creating an object of date d and calling it as d.month, d.day, d.year, and we are returning d, that is the copy is returned over here. When we return d, that will be copied into a variable called as today. Today is an object created for a date structure. When create date 1 returns the structure that is copied into today. Second statement here, create date 2, is having the first parameter as a reference parameter, ampersand today. When ampersand today is there, ampersand today now contains the address of object of date structure, which is having 3 parameters, month, day and year. Now you can see whenever address is passed, pointer variable is there here in the function date star d. Using this d, we are accessing it now as follows: d arrow operator month, d arrow operator day, d arrow operator year. These values are assigned now. First, 1 is assigned to month, 18 is assigned to day, 1972 is assigned to year. We can see now in detail how the memory structure will be there when parameters are passed over here as a reference parameter. Create date 2, pointer is the first one because we are passing a reference parameter over here. Then d is a pointer over here which is keeping the address of today.month, today.day, today.year. We can see the address over here. 0x1000 is the address. By taking that address, it is going to that memory location and accessing all the consecutive memory locations. Month is assigned, then day is assigned, then year is assigned. The advantage of using pointers to structures as function arguments is whatever changes we do it in formal parameters, that is in the functions, that will be reflected back into actual parameters. So these are the 3 methods using which you can pass the structures to a function as the arguments or parameters. First one is individual elements, we can pass it as parameters. Second one is value parameters, and the next one is reference parameters. Hope the concept is clear. We will see the remaining topics in the coming videos. Thank you. Hi, in this section we will learn about the following. First we will see what is a union in C language. Then we will look at the example using union in C language. Then what is the difference between structures and unions? And at the end we will look at the applications of unions. Let's begin with understanding what exactly a union is. A union is a user-defined data type which works and declares initialize, assigns, and access the data elements, same as structures in C language. In structures, memory is allocated for each data element separately. If I have 3 data elements, one is integer, another one float, another one character array, then the memory will be allocated for integer, float, and character. Whereas in union, all data members share the same memory location. That is a major difference between structures and unions. Then comes a question, how exactly the compiler decides how much memory is to be assigned for a union. The decision of a compiler is based upon the largest data member of a union. That is, the size of a union is taken according to the size of the largest data member in the union. We will look at this one with the help of an example. Here is an example. A union is declared same as a structure, except the difference is, instead of having a keyword struct, we are having a keyword union. Now having 3 data members, one is a character array, another one is float, another one is integer. We are naming this object name as uEmployee, that is UEMP. Let us assume that the same data members are placed into a structure. Then how much memory these 2 data types will occupy? Now we are calling size of operator to know how much exactly the memory is going to be occupied by these derived data types. When we call the size of union, it's going to give you 32 bytes. Whereas when we call size of operator for a structure, it's going to give you 40 bytes. Now, why there is a difference between structure memory assigned and union? Union is going to be allocated the memory based upon the highest, that is the largest size of the data member. Here it is a character array which is occupying 32 bytes. Each character occupy 1 byte, and an array of size 32, that means 1 multiplied by 32 gives you 32 bytes. Whereas for a structure, 32 bytes for a character array, 4 bytes for salary, that is float, and 4 bytes for integer will give you 40 bytes. Assuming that float occupy 4 bytes and integer occupy 4 bytes. Let's see the differences between structures and unions. First one is the keyword. First one uses a keyword struct, whereas union uses a keyword union. Coming to the size of the structure, when a variable is associated with a structure, compiler allocates the memory for each member, just now what we have seen with an example. Whereas when come to the part of union, compiler allocates the memory by considering the size of the largest memory, that is, just now we have seen 32 bytes for character array. Now, how the memory is going to be shared? Here, each member within a structure is assigned unique storage area, so they share their own memory location. Whereas for a union, memory allocated is shared by individual member of union. Now comes the difference here in value altering. Altering the value of a member will not affect other members of the structure because they are having independent memory locations. When comes to union, altering the value of any of the member will alter other members' values. Accessing members. How do we access the members? Here, individual members can be accessed at a time because they are having independent memories. All data members can be accessed at a time. Whereas for a union, only one member can be accessed at a time. since they are sharing the same memory location. And at the end, initialization of members. Several members of a structure can initialize at once. All together can be initialized at once. Here, for union, only the first member of a union can be initialized. These are some of the differences between structures and unions. At the end, let's look at the applications of unions. Unions can be useful in many situations where we want to use the same memory for two or more members. For example, say we want to implement a data structure called binary tree, where each leaf node, that is a terminal node, also called as external node, has a double data value, while each internal node has pointers to children nodes, that is to two childrens, but without any data. Then we can allocate the memory using unions. Then we can efficiently use the memory structure. That's all for now. We will see the remaining topics in the coming videos. Thank you. Hi. In this section, we will learn about what are bit fields in C language and an example using bit fields in C language. Let us begin with what are bit fields in C language. In C language, we can specify size of the structure and union members, that is the data members of both structures and unions, in terms of bits. The idea behind using bit fields is to use the memory efficiently. As a programmer, when we know that the value of a field or group of fields will never exceed within a small range, then bit fields are very useful to use. Let us understand the concept with the help of an example. We have a structure date with first data member as date D is of type unsigned integer, which is assumed to be occupied 4 bytes of memory. Then M, that is month, again is of unsigned integer, is assumed to occupy 4 bytes again. Same thing for year also, is an unsigned integer assumed to occupy 4 bytes. Now, in the main function, when we are calling size of operator here to know the size of the structure occupied by date, then each member is occupying 4 bytes. So a total of 12 bytes are now going to be occupied by the structure date. We are initializing the structure in the second line in the main function with some values. 31 is assigned to day, 12 is assigned to month, 2019 is assigned to year. And in the last printf statement, we are trying to print all the member values one by one. That is, individual data elements are printed here. So we will get the output something like this. Now, how efficiently we can use this memory here is, let's see using bit fields how we can use the memory efficiently. First data member, that is day, which is going to store the values between 1 to 31, that is the maximum value here is 31. If it is converted into its binary equivalent, it is going to be 11111. That means that how many bits we are using it among the 4 bytes. 4 bytes in the sense 4 multiplied by 8 gives you 32 bits. Among available 32 bits, we are utilizing only 5 bits. So here C allows you to use only those number of bits which are used. So we can save over here 2 bytes by indicating :5 for day. Same way for month, that is 1 to 12 are the months. So maximum value what we can enter it in month is 12. If it is converted into its binary equivalent, it will be 01100. If we call the size of operator to know the size of a structure, then it is going to give you 8 bytes. Same thing to be printed over here gives you the output. 31 is assigned to date, 12 is assigned to month, and 2019 is assigned to year. So here, with the help of bit fields, we can use the memory efficiently and we can work out on the number of bits, how many number of bits we can use among the number of bytes available. We will see the usage of bit fields with the help of examples. That's all for now. We will see the remaining topics in the coming videos. Thank you. Hi, in this section we will look at the following. We will start with first introduction to enum and typedef, which are the user defined data types in C language. Then individually we will look at what exactly enum is and an example using enum, followed by we will compare enum with macros and what is typedef, syntax for declaring typedef, and at the end we will see an example program using typedef. We have already gone through the data types in C language in a separate video where we have covered the primary data types, and separately we have covered pointers, arrays, structures, and unions. Enum and typedef are the two user defined data types. So they fall under the category of user defined data types. Let's begin and see individually what are these two user defined data types are. Let's see what exactly an enum is. Enum or enumeration is a user defined data type. It is mainly used to assign names to integer constants. That is, the names makes a program more easy to read and maintain the program. Enum is a keyword among the 32 keywords provided by C language. Here is an example to understand how exactly enum is declared and work. Enum followed by state is the name what we are giving it, with two values. Working assigns a value 1, not working assigns a value 0. Another example, say boolean, true assigns 1, false assigns 0. With the help of an example, we will see how exactly we can access these names. Here is an example using enum. Let's say, for example, week, days of a week, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. We are assigning the names over here. In main function, we are creating a variable to access these names. Enum week followed by day. Then we can assign any value day equals to, say for example, Wednesday. By default, the values starts from 0. So if we don't initialize any value, by default a value assigned is 0 for Monday, then followed by Tuesday will be assigned a value 1, then followed by Wednesday will be assigned a value 2. Let's see some more information about enum. If we are creating enum with two different names, then they can share the same value. For example, working assigns 1, I can assign 0 to both not working, as well as suspended. These are the three states of an say employee or a person working. Working assigns 1, not working assigns 0, and suspended assigns 0. So here both the names are sharing the same value. By default, if you don't assign any value, the first enum name will be assigned a default value 0. And the value assigned to enum names must be some integer constants. That is, the value must be in the range from minimum possible integer to maximum possible integers. They cannot exceed the range either way, that is minimum value as well as maximum value. Let's see what exactly the difference between enum and macros. We can also use macros to define names constants. What we can do it with enum, we can use it with macros as well. That is, using hash define, we can declare it something like this: hash define working 1. Macro name is working and macro substitution will be 1. Whenever the name working comes, a value 1 will be substituted over there. Same way, not working is assigned 0 and suspended can be assigned a value 0. Then if we can use macros in the same way like enum, then what exactly the difference is? Here is the difference. There are some advantages of using enum over macro. When many related name constants have integer values. First one is enums follow scope rules. That is, the scope in which the variables are assigned are local, global. The same rules what are applicable for variables are applicable for enums also. Second one is enum variables are automatically assigned values, whereas we have to assign the values for macros. So this is the advantage of enum over macros. Let's see what exactly a typedef is. Typedef is a keyword in C language which tells the compiler to assign an alternative name to already existing data types in C language. The keyword typedef works in association with user-defined data types in cases if the names of data types turn out to be a little complicated or difficult or complex for a programmer to use it. Let us see the syntax for declaring a typedef. Here is the keyword typedef followed by the existing name of the data type, say integer, unsigned integer, long integer, double or anything, then followed by the alias name, that is a user defined name, you can use it, followed by the semicolon. Here is an example: typedef unsigned int. In a program, I am now going to use unsigned int many number of times. So instead of typing unsigned int, I can use the name, user defined name UI. So wherever unsigned int is there, I can use the name UI. It's not only applicable for basic data type, you can even declare typedef for derived data types as well, that is a structure. Once we declare UI, now I can declare the variables, say I and j, both are of unsigned integer type. Now I am not declaring unsigned integer again, but I am using the name UI, that is the typedef. So I and j are of unsigned integers now. Now, typedefs are not only used for basic data types, that is primary data types, they can be used for derived data types as well. Like syntax for using with a structure: typedef followed by struct is a keyword followed by structure name and the same member list with type. At the end you can give the name of type. Once we declare this variable, we can use this variable something like this: name of type followed by variable name type1 comma type2. You can use it instead of using struct structure name, we can use just this name of type. Example using type def. Let's see a structure with a name professor details. So professor is the name of a structure over here. Type def is a keyword followed by two member list, professor name of some size and the salary in terms of integer. We are declaring here type def prof, that is short form of professor, and in main function we can declare a variable pf of type professor. So instead of using long names, we can use short names over here, and while reading we are using pf dot pname and pf dot salary. So that is the advantage of using type def. That is, instead of typing the name again and again, we can use the short names, that is user defined names. That's all regarding type def. We will see the remaining topics in the coming videos. Thank you. Hi, and welcome to another programming challenge. Here in this programming challenge, we are supposed to store and display the details of some hardware items as shown in the table. Here is the table given. The structure of this table is as follows. We are having three columns over here: name, price, and category. These are the three columns given to us. Now, for each item, say for example nuts, there is a different price in the first month, and there is a different price in the second month, and there is a different price in the third month. And here we are going to specify the category of the item. Similarly, for the second item, say bolts, some price in the first month. Here are the months, 3 months are there. There are some variations in the prices of the items. Here is the categories. These two are mechanical category, whereas the third item, oil, having different prices over here for 3 different months, is a general category item. Now here we need to create a program which can store the data of such a structure and display it in this particular format. Now let us try to understand what exactly the requirement is. At this particular point, I just want you to pause the video and try to implement using nested structures. I'll provide some solution guidelines using which you can easily implement it using nested structures. Here are some of the few solution guidelines are. First thing, try to identify how many number of columns are there. 1, 2, and 3 columns. Then internally, is one column is having only one data or multiple data? Like name is having only one category of data, category is having only one type of data, whereas prices are again 3 types of prices are there in 3 different months. So again, this type of variables should be again a structure. That means that if I am creating a structure with a name, say item, which is having say name as one data element, category as another data element, and price as another data element, then I must have price as a separate structure which should be again containing 3 type of data element of some integer type to be stored it such that when I call this price structure variable, I can store multiple values over here whenever I am going to place the data into the second column of the original structure item. Using this solution guidelines, let's try to build a program and solve this programming challenge. I hope those who are well aware with nested structures concept, a structure within another structure, as we have seen in the concepts of nested structures, how to use the data of normal structure and nested structure. Further, if I want to give some more hints, I'll be creating a variable for this structure. This is the regular structure or main structure, you can say. If I have a main structure variable name as IT for items, and internally for price I'll be creating a variable say P. How do you access the data elements of structures is, if I want to access this name, I'll be accessing it directly as IT dot name. If I want to access category, I'll be using it IT dot category. But I want to access this one, data elements, then I have to access using this internal variable say P. How do you access it? IT dot P dot, then the data members of this one, the first one or second one or third one, using second dot operator. We are using dot operator because it's normal variables. If we want to access pointer variable data, then we will be using arrow operators that we have already seen in the concepts of structures. I hope this information and the solution guidelines are enough to pen down and write down the program to solve this particular programming challenge. Let us continue and build a programming challenge solution. First thing is, I have to create a structure. I'll assume that the structures are global, so I'll create it before main function. So the first structure, which is nested one, inside one, I'll be creating that structure first. So structure price, say integer P of how many such data values we have to store for 3 months. So I'll be creating an array for storing 3 different values. Once I complete this structure, I'll be giving the variable name for this structure. Say both are PP over here, so I'll just make this one as PR for price. Then the actual structure now. Structure, what is the name of the structure? User defined name. I am giving it as item. We can give any other name. What are the columns required under item are? There is a name, so it should be a character array of some size, say for example 20, and another one is a category. Category is also a string, which is going to be a character array. These two are character arrays stored over here, followed by, now comes the nested structure, that means price. Price again is a structure which we have already declared it. So struct price, you can see over here when I'm typing it, it's coming down the name over here, price. I'll use the name over here P. Okay, I'm not declaring the variable for structure item. Even you can declare the variable name here itself, or you can create it in the main function as well. Let's create the first variable name for structure item. Structure item, say I'll give item IT. How many data elements you want to store it? Say we have seen the example nuts, bolts and oil. So how many? Let's take an example 3 only. If you want more, you can give some more size as well. Now, what are the other variables required? Whenever we come to this variable declarations, we will be declaring the variables. Now, first thing is I have to read the data. How do you read the data? Reading the data is for multiple structures. For that one, you have to create a loop. Say for example, integer I equals to 0, which I have to declare the variable I less than 3 data elements, 3 items we are storing it. So this one I have to repeat. What I have to repeat over here, I'll say we have given a message to enter the name for item number, say item number 1, item number 2, item number 3, like that, and we are displaying that value with I plus 1 because I value is starting from 0. Now we will be reading the item name using scanf function, and the item name is stored in the main structure. So I'll be using it over here as %s for reading it in item of I dot name. This is the name of the structure we have read. Once we got the name of that structure, we can read the category as well, but in the sequence, if we go after name, we have prices. So for prices, we have 3 different prices. That means that for each one I have to use again a iteration. For that one, I'll be using a loop again. Here we will be giving a message to the user. Within the loop, enter price for say month percentile D. For which month? Again here J value is starting from 0, so J plus 1. For the first time, 0 plus 1 is the first month, then second month, then third month. Like that we will be reading using scanf function percentile D. Now here when we are reading the price, we have to use this variable P dot the price. Price for which one? Price for the J1. J1 are 3. So this is not the normal variable. This is a structure within another structure variable. Now once we are done with this, we can read the data for categories. Read using scanf, and category is again string type, and it is now going to be, we are not using ampersand over here because it is a string dot category. Now once we are done with reading part, let's try to display the data. But remember, we have to display the data in a tabular form. So I'll be using the formatted statements over here. 3 column names I have to display. The first one is the name. Use some tabs over here so that I can display the price. Then use 2 more tabs to display the category. Now here we have to display M1, M2, M3, that is for first month, second month and third month. Within the next line again use one more tab for printing it, something like say for M1 month 1. Use one more tab for printing the data for M2. Same one more tab for printing M3. Now the next line is used to display the next contents in the coming lines. Now here we want to print or display the data. Again the data is multiple data, we have to print it. Now be careful in printing the data. Over here we have to use a loop again. These values we have to declare it, I value and J value index, what we are using it over here, I less than 3 and then I plus plus. Now within this printf statement only your complete data will come. That means first thing what you have to print over here is the name of the item. Then using one tab we are going to display what? The price for each month, that is percentile D for the first price, then slash T, percentile D for the second month price, slash T, and percentile D for the third month price. Then at the end we are going to display the category. For that one again one more slash and then percentile S. These are the things what we have to display it. The first one is the name. Name is stored in structure name of I dot name. Second one is structure name of I, that is the first structure, dot internally I have to use prices. Prices, there are 3 prices over here. P dot, I can use first price as price of 0, then price of 1, then price of 2, or else we can use again one more for loop. I am avoiding one for loop over here for printing the data. So I can use directly over here PR of 0. This is first price we got it. Same way I can use over here the same thing, PR of 1, then PR of 2, then dot category. Let us see by using this printf can we get the complete information. Once we are done with this for loop, let's build. We have not yet declared I and J, so let us quickly declare these variables over here. See the logs for the errors. Here I is not declared, so I'll be declaring these variables I as well as J. Let us build again. No errors, no warnings, perfect. Let us run. Now you got the information over here asking the details over here as follows. Enter the name for item number 1 we are getting. That means that here for loop starts from 0, we are getting I plus 1, that is for first item. Now we have to enter the name of the first item. Say the first item is say nuts. For the first month the prices for nuts, let's say 10, then 11, then 12. This one falls under the category of mechanical product or mechanical item. Let's enter the detail for now. We are getting item number 2. This value I is now incremented to 1. 1 plus 1 is 2. These details again we have to repeat. This is for say bolts. Let's enter for the first month. Bolt value say 1, then 2, then 2. Category is again mechanical. Item number 3 is say oil. For the first month, oil is say some 100. Then second month remains 100 only. Then the third month it changes to say 104. Its category is say general category. Now, once we have entered the details, we are getting almost everything perfect. The heading, the name in the table, first column, then we got price as the second column, then internally we are getting, but you can see some display problem over here. After printing it, the first data, we are not using /n. Because of this not using of /n, we are getting this particular data to be printed within the same line. Let's change it. Here we have to give /n to get the output in the next line. Let's build and run again. Category is general category. Let's concentrate on the output now. Here is the heading. What we are getting is hardware item details is the heading one time printed, and this one is the table like structure where this was supposed to be printed, as the first row is having name printed as the first column name, then price printed and category. Within price we have first month price. This is 1, this is 2, this is 3 rows, and for the second month this is the price, for the third month this is the price. That means that we can easily now identify for nuts. In the first month the price is this much, and in the second month price is this much, and in the third month price is this much, and it is of mechanical category. Similarly bolts, similarly oil, prices are different in 3 different months, and it is of general category. Perfectly. This one is a programming challenge solution what we have achieved perfectly. Hope this solution matches with your effort or the challenge solution what you have done. If you have any queries, you are welcome in the question and answer forum. We will see the remaining programming challenges in the coming videos. Thank you. Hi and welcome to another programming challenge. In this programming challenge, we will see how to develop a menu-driven application program to work with the records of employee as shown here. Now, this is not just a programming challenge, it is just like a simple mini project which will be helpful for the students who will be very much eager to develop a small project. But this one is not using a concept of files. Without the concept of files, we are trying to embed most of the concepts of C language what we have learned in this particular course. Now, what is the requirement over here is we need to develop, first thing is a menu driven application program. What do you mean by this menu driven application program? Is here is the menu what you can see it over here. You can give this menu even at the starting of this program as well. Now, what exactly this menu is having? This menu is having some options like 1 is for addition, 2 for deletion, 3 for modifying, and 4 for exit. Let us say if user enters a choice 1, that means that we should allow the user to add some more records of this particular form. What are these particular forms are? ID, name, designation, salary. These are the contents of one employee structure. Again, this is the contents of another employee structure. That means that you can see over here one employee structure data what we have entered it is displayed over here, and the second employee structure data is displayed over here. Once user gets this menu, say for example if he wants to continue adding the contents Say if user enters choice 1 again, that is for addition of data, then the current contents should be displayed first. That means that currently these many number of records are available. Then followed by, if you want to add the records, you press 1. Say again, you must have these options to read. What are the details of the employee? ID, name, designation and salary. Once you got this information, you have to place it again here and display the data. Earlier there were only 2 records. Now we got, after addition, 3 records. Again one more message is there. Do you wish to add the records? If yes, then press 1. Like that we should proceed. Say at some point of time, user wants to perform the modification of the records. Then user can enter the option 3 for modification. So here the option entered is 3. Once 3 is entered, first you display the current contents. What are the current contents of the structure are. Then if at all user wants to perform modification, then he must be entering the details of that particular employee. Say for example, this record of employee ID 2. You can watch over here, current name, current designation and the current salary. You can modify it over here, all the things. Currently I am giving the same ID, same name, but you can see the designation has been changed from PA to senior officer, and the salary is also updated or upgraded from 2000 to 2004. Immediately it must affect that record over here and you must display that particular information. The remaining information is as it is, intact. If at all you want to modify some more records, you can press 1 and continue. Otherwise, this time you want to perform, say, deletion operation. Then it will be something like this. You will be having an option to enter over here for delete. For delete, user will be entering value 2. Once you give value 2 or 1 or 3, whenever we are giving some option, you first of all print the current contents of the employee structure, so that user will have a clear idea what he is going to do, which record is to be modified, which record is to be deleted. So in this case we want to delete a record. So enter the ID for deleting the record. Say for example 1 with John record, designation clerk and whose salary is 1200. It will be something like this. After performing deletion, how many number of records were there earlier? Earlier there were 3 records. Now you can see automatically it is displayed over here is the number of records left out are 2, and we are displaying only those many number of records which are currently available. So John record is gone now. It's not shown over here. It's displaying only the information of these 2 employees. Then again you can continue. If you want to wish to delete some more records, then you can press 1 and you should continue. So here there are many concepts of C language are used. Some loops are used. We are reading the data. Structure is used. Go to statement we can use. So there are many things we can make use of the concepts what we have learned in this particular course and put down all the logic together to generate this type of mini project. And at the end, user wants to exit. Say for example, I want to say I have not entered 1 to proceed further for deleting the record, option say 4. So then again I got the menu over here. Now I want to terminate the program, enter 4 and the program will be terminated. I hope this much of information is enough for you to pen down the logic and write down the program. Let us see how well you can write down the program and achieve this programming challenge. For the solution, I'll be providing the code in a separate file. Then you can match that particular program with your solution, whatever you have generated it. If at all any problem is there in the code, I am here to support you, and you can ask any question in the question and answer forum, or you can see the contents of the file which I am attaching as a .c file, which is having the complete solution. All the best for this mini project type of programming challenge. We will see the remaining challenges in the coming videos. Thank you. Hi and welcome to another online coding challenge on HackerRank. Today's challenge is boxes through a tunnel. Let us see what exactly the problem is. You are transporting some boxes through a tunnel where each box is parallelly piped and is characterized by its length, width and height. The height of the tunnel is given as 41 feet and the width can be assumed to be infinite. That's not a worrying factor. A box can be carried through the tunnel only if its height is strictly less than the tunnel's height. Find the volume of each box that can be successfully transported to the other end of the tunnel. Note, boxes cannot be rotated. Here is the input format. The first line contains a single integer n denoting the number of boxes. N lines followed with 3 integers separated by a single space, each indicating length, width and height respectively, which are the length, width and height in feet of any ith box, where n ranges from minimum 1 and maximum n, and length of each one should range again from 1 to 100. Output: for every box from the input which has a height less than 41 feet, print its volume in a separate line. Say for example, this is going to be the sample input. The first line, specify n value here. The first box is really low, 5, 5 and 5, length, width and height. So it can pass through the tunnel and its volume will be 5, 5, 5 multiplied by this one will give you 125. The second box is sufficiently low. Its volume is 1, 2 and 40 multiplied. Okay, no problem. The third one is exactly 41 feet tall. You can see the height is given over here. So it cannot pass. It should be less than that. The same can be said about the fourth box as well. Same thing, the height, since it is less, since the height is greater for these two boxes, they cannot be passed through the tunnels, whereas these two boxes can be easily passed through the tunnels. Then we have to calculate their corresponding volume. This corresponding first volume is going to be 125 and the second volume is 80. So the volume, what we need to calculate is going to be length into width into height will be the volume. Here is the task what we have to accomplish. First thing is we have to define 3 fields of type integer, length, width and height, and we have to complete this volume method, and then one more method which returns an integer value by checking the height of the box is lower than the maximum height. It returns 1 if the box height is lower than the maximum height defined. Here is the maximum height defined. Maximum height defined is 41 according to the problem definition. Here is the problem definition says the constraint of the problem is it should be less than, here is the constraint of the problem is the height of the tunnel is 41 feet. So we have to complete this task. So the problem definition is we are transporting some boxes through the tunnel and box have the properties of length, width and height. We have to input the values. If the height is sufficiently less than this 41, then we can pass the boxes through the tunnel, otherwise they cannot be passed. If they are through the tunnel, then we have to calculate the volume, and the volume is given by length, width and height product. Let us now quickly get into the code. Here we have to specify the fields of type integer, length, width and height. Return the volume of the box. Volume of the box is written as length multiplied by width multiplied by height, but they are not directly accessible. Here you can see length as well as width as well as height. They cannot be directly accessed, but they can be accessed through the variable or the object of box structure. So I'll be using b dot multiplied by b dot width multiplied by b dot height, and this method returns 1 if the box height is lower than the maximum height. So you can check with if condition, or you can directly say return b dot height should be less than the maximum height. Maximum height is defined here as a macro. So what this condition will do, whatever be the height of the box is there, it will compare it with maximum height, and the maximum height is defined here as 41. If this value here is less than 41, then 1 will be returned, that is true is returned. So that you are checking the condition here, is lower than max height of box of I. If it is 1, that is true, then print the volume. Get volume function will be called. From get volume, what we are doing, we are returning the volume as product of length, width and height. So these are the things what we need to fill up. That's all regarding the code. Let's test the code by running. Congratulations, it has passed the sample test case. Let us submit the code, going through all test cases. Yeah, compiler message success, gone through all the test cases here, and we have earned these many points, and we are just 20 more points to get the next gold badge, the next star, and the rank you can see has reduced from 7,000 to now 5,000. So we have successfully solved this boxes through tunnel challenge. We will continue with the remaining challenges in the coming videos. Thank you. Hi, and welcome to another online coding challenge on HackerRank. Today's challenge is small triangles, large triangles. See here, we are 20 points behind to get the gold badge, and we are in this current ranking. Once we will solve this problem, we will get a score of 30 that we will cross. Let us see the problem definition. You are given n triangles, specifically their sides AI, BI and CI. 3 sides are given. Print them in the same style but sorted by their areas, from the smallest one to the largest one. That is, the triangle with the smallest area is to be printed first, and the triangle with the largest area should be printed last. It is guaranteed that all the areas are different. You will not get any areas of the 2 triangles to be same. The best way to calculate a volume of the triangle with sides ABC is Horn's formula, that is what we learned in mathematics, under root of P into P minus A into P minus B into P minus C, where P is nothing but A plus B plus C by 2. Input format is the first line of each test file contains a single integer n. N lines followed with A, B, C, on each separated by single space. Constraint of the problem is the n value should range from 1 to 100, and the sides A, B, C values should not exceed 70 and should not be less than 1. And there is a condition that A plus B side should not be greater than the third side. Same thing is applicable for other remaining 2 sides as well. Same way, A plus C should not exceed the second one, that is B. Same way, B plus C should not exceed the first one, that is A. Print exactly n lines. On each line, print 3 integers separated by a single space where A of I, B of I and C of I corresponding to the triangle. Here is the sample input. Sample input is n. For the first one, A, B and C. The square of the first triangle is 84. The square of the second triangle is 30, and the square of the third one is 6. If we arrange these squares in their ascending order, then it will be 6, 30 and 84. That is for the third one. So here 3, 4, 5 is printed first, that is the smallest one. Then the next one is 30. 30 is the smallest, second smallest, comes from 5, 12 and 13. And the last one, that is the 84. This is the order in which we have to print it. So this is the sequence what we have to get it. So for doing this one, we can apply any sorting technique. easiest one among all is bubble sort. Say for example, if we have say 84, 30 and 6, these are the data elements. Say for example, these are to be sorted. How bubble sort works? Take a index I, initialize it to the first one, take a index I plus 1, compare ith element with I plus 1th element. If say I plus 1th element is smaller than ith element, immediately swap it. Then again I is incremented. So I is currently pointing it here. This one is now going to be I plus 1. Then these two elements are compared, 6 and 84. Yes, so it is 6 here. 6 and 84 will be swapped, so that 36 will go up, 84 will come down. This is the completion of the first iteration of bubble sort. Let us see the code, what we have to do it here. Here we need to sort by area. So I'll just write down the code. Sorting can be done by taking any sorting technique. The easiest among all the sorting technique is bubble sort. So we will take that logic. I'll write down one more function, say area. Let us have a function named as area, takes structure as a parameter. Structure name we have triangle. Let us say triangle T. We'll declare three local variables here. A, which takes T dot A as the first value, then B as T dot B, assigns the value. Same way C assigns T dot C. Then return A plus B plus C multiplied by A plus B minus C multiplied by A minus B plus C multiplied by, last one is minus A plus B plus C. This is the area what is going to be returned here. So let us apply bubble sort technique. I'll explain that technique as well. First of all, I'll finish the code. So bubble sort to work, we need two for loops or two loops. I'll be taking two loops here as int I assigns 0, I less than n, which is passed as a second parameter, and I plus plus. Need an inner for loop, takes j assigns I plus 1, j less than n again, j plus plus. What we need to check here is if area of the triangle TR of I, if this value is greater than the area of the second one, that is TR of J. If it is so, then we have to swap. For swapping, we required a temporary variable. Struct say triangle takes TR of I takes TR of J. Swapping is a three-step process. TR of J now takes lastly temp. This one is a simple bubble sort. How it works, I'll tell you the logic here. First, let us run the code and test. Yes, it has gone through the sample test case. Now I'll explain you here how exactly this bubble sort works. Here is the array area we are calculating. Let us say area is calculated as 84 first one, 30 next one, 6 next one. Indexes 0, 1, 2. So area is a function. TR is the name of the array in which triangle we are going to have the contents of this area. Now area function, what we are doing it here is we are calculating the area by multiplying these possible values given in the constraint, where a value is now assigned to this local variable a passed as a parameter, b value is now assigned to this local variable b, c value is now assigned to this local variable c. And now that's how the area is now going to be calculated for each one. Let us assume that the area is calculated and return over here for the first time. If area of TR of I means I starts here. What is the value of j? J is here. So area of TR of I, yes 84, is greater than 30. Yes, true. If it is true, then we have to swap these two. How we are going to swap it? take a temporary variable and place tr of I, that is nothing but 84. Then tr of I takes tr of j, that means here we are going to get the element 30. I'll write it down here. 30 is placed and temp is now placed into tr of j, that is nothing but 84. That's how these two elements gets swapped. Index 0, 1, 2. So j value is further incremented. J value, once it is further incremented, it is now going to be here. Again these two elements are swapped such that 36 and 84. After the completion of first iteration, the contents will be like this. So now this time 30 is compare with 6. Yes, 30 is greater than 6. 6 comes up, 30 goes down and 84 as it is. Again these two elements are interchanged, same like this swap takes place. Now the elements are there in sorted order. That's how the working of this sorting is there, and this is the function area we are continuously calling, repeatedly calling here. Let us quickly submit the code and check processing the remaining test cases. Here is, congrats, you have earned your 5th star. So we are currently with 5 stars now for the programming challenges for C language. To continue further, we will press continue, and we have earned 30 points with this challenge. So we have solved 23 challenges out of 25 till now. So we are left out with only 2 more challenges, and you can see the rank is now further reduced to 3986. We are ready with the next 2 challenges as well. We will see the remaining challenges in the coming videos. Thank you. Hi and welcome to another online coding challenge on HackerRank. Today's challenge is post transition. Let us see the problem definition. We live in a big country. This country has towns count, number of towns in it. These many number of towns are there in a country. Each town has some post offices in which packages are stored and transferred. Post offices have different inner structures. Specifically, each of them has some limitations on the packages it can store. Their weight should be between some specified weight, minimum weight and maximum weight, inclusive of these two, minimum and maximum weight, where minimum and maximum weights are fixed for each office. They have their own limitations. Every office will have their limitations with set by these two values, min weight and max weight. They cannot go beyond this range. Packages are stored in some order in the office queue. That means that they are processed using this order when sending and receiving. That means that every office maintains a queue for the packages. Whenever the packages are to be sent or receive, they will follow the data using this queue property. Usually queue follows first in first out property. Sometimes two post offices, even in different towns, may organize the following transaction. Here is the transaction. The first one sends all its packages to the second one. The second one accepts the packages that satisfy the weight condition for the second office and rejects all the other ones. These rejected packages return to the first office back and are stored in the same order they were stored before they were sent. The accepted packages move to the tail of the second ones. That means that they are appended at the end of the existing packages, which follows queue's FIFO property in the same order they were stored in the first office. Now our task here, you should process several queries in your program. You will be provided with the following structures. These are the number of structures provided. Package is one of the structure, post office is another structure, town is another structure. Here these are nested structures. Town contains post offices, post office contains packages. In order to complete this task, you should fill the following functions. And the first function among the task to be completed is print all packages. Here is the format in which we have to print it. Given the town T, print all packages in this town. They should follow the following criteria for printing. First line should have the town name, followed by one tab should be used here to print this 0 or 1, whatever it is. Then followed by again 2 more tabs here to print the IDs. Same thing follows here for 0 and for 1, the same thing followed, 1 tab, then followed by 2 tabs. What is this 0? What is this 1 means? Here is 0, 1, etc. are the numbers of post offices. 0 post office, 1 post office, these are the numbers of the post offices. And ID 0, ID 1 are the IDs of the packages from 0th post office. This is regarding the first information of post office. This is 0th post office. This is first post office, you can say. These are the IDs in the order of its queue. ID2, ID3 are from the first ones. There should be one tab /t, what we have described here, symbol before the post office number, and 2 /t's here before the symbol IDs. This is the task what we need to do it in print all packages. The second function in the list to be implemented is send all acceptable packages. Now given the towns as the parameters, source town as well as the target town, and post office indices will be given as source office index and target office index. Manage the transaction described above between the post office, that is source office index in town source and the post office index in town target. So for this packages to be acceptable, they should fall within the range of minimum and maximum weight. Then only we can say these packages are acceptable. We need to send all these acceptable packages from the source town to the target town. The next function in the list to be implemented is town with most number of packages. You will be given all the towns. Find the one with the most number of packages in all the post offices altogether. If there are several of them, find the first one from the collection of towns. So we need to find the town with the most number of packages. This is the third function. And here is the fourth function. Find town. Given all towns and a string name will be given. Find the town with the name. It's guaranteed that the town exists. Yes, the town will be existing definitely. So we need to find the town, whatever the name has been given. These are the 4 functions what we need to implement it. Let us see the input format. The first line input contains a single integer, that is the town count. Totally how many number of towns are there. Follows each describing a town. Let us directly see the example here. This will be the sample input. The first parameter, that is the integer value, indicates the number of towns. So the first one contains the number of towns, that is the town count, and this one specifies the name of the town, town name. This town contains how many number of offices. So this 2 specifies here number of offices, that is nothing but office count. So this 2 specifies there are 2 offices. Now the next one specifies, first one package count, that is the total number of packages, and this 1 specifies minimum weight and this 3 specifies maximum weight. So these are the 2 packages that is specified by these 2. This 2 means these are the 2 packages. What are these details of these packages are? The first one, A, specifies the ID of the package, and the second one specifies the weight of the package. So this first one specifies the ID and second one specifies the weight. Same way here, first one specifies the ID, second one specifies the weight of the package. This is regarding the first office, and this one now specifies again the package count. So this one specifies package count, and this 2 specifies minimum weight and maximum weight. Same thing, since it has one package, that ID is C and the weight of the package is 2. This completes the second information. So there are 2 offices and there are 2 packages in this one. So this is the information regarding this 2 from town A. This is regarding 1 and this is regarding 2, second office. So first office contains 2 packages A and B, and second office contains 1 package only C. That's all regarding the information regarding town A. Here starts information about town B. Now how many number of offices town B contains? Town B consists of only 1 office, and this office contains 4 packages. These are the 4 packages which describes here. Each one indicates ID and weight, and here this one is going to be the number of packages followed by minimum weight and maximum weight. Here completes the information of town B. This completes the information for town A. This completes the information for town B. Here this 5 specifies number of queries. So total of how many number of queries we have? 5 queries we have. These are the 5 queries in sequence: 1, 2, 3, 4 and 5 queries. Whenever query type 3 is there, directly print. So if it is 3, directly print town with most number of packages. So here is 3 as well as here is also 3. So we are just going to print. Here also going to print town with most number of packages. Now come to type 2. What do you mean by this 2 is? This one, B specifies the source town and A specifies the target town office respectively, and this 0 specifies the source office index, and this 1 specifies the target office index. And if it is 1, so it can be only 3 possibilities here. Number of queries specifies here there are only 3 possibilities, either 1, 2 or 3. 1 means here these are the 2 options, 2 means there is only 1 option, 3 means these are the 2 possibilities here and here. So for 1, what is this one is? The town name for which the package should be printed. Here the town name for which the package should be printed. This is the town name for which the package should be printed. So this is going to be the sample input. I'll just make it clear one more time here. The first sample, the first line integer specifies that there are 2 towns. Here is town A and town B information. Town A information starts from here and here. Every town consists of number of offices. There are 2 offices in town A. This is regarding the information about the first office. In first office there are 2 packages, minimum weight 1, maximum weight 3, and these are the IDs of the packages. Package ID A with the weight 2, package ID B with weight 3. Coming into the second one. Second office contains only 1 package, minimum weight 2, maximum weight 4. That package ID is C, whose weight is W. This completes the information regarding town A. Let us come to town B. Town B consists of only 1 office, which consists of 4 packages. D, E, F, H are the IDs, 1, 2, 3, 4 are the weights. And the last part of the input is the number of queries. Number of queries, first integer will be 3 possibilities only, either 1 or 2 or 3. Here are the possibilities of 1. 1 here means directly print, directly town name will be given for which the packages should be printed. Whereas for 2 means from source B town to A town, this source office index to target office index, this has to be shifted. And for 3, the town with most number of packages should be printed. So this input scenario can be seen something like this. town A, there are two towns, town A and town B. Two towns consist of, first town A consists of two post offices. This is first one contains the information regarding A and B packages, and post office 2 consists of C package. Here, whereas town B consists of only one post office with 4 packages D, E, F and H. So this is the query, and based upon this queries we have to write down the functions. Hope by keeping this information in mind we will see the program for post transition. Here is the program. We will be seeing the program and its execution first, then we will upload the same file into the HackerRank website. So here a package. Every package consists of two things, its ID and its weight. And here you can see a post office consists of number of packages along with the package count, minimum weight and maximum weight, and the total number of packages what it consists of. And then the town consists of the number of post offices. So here this post office is nested to this one, and here packages are nested to this one. So a town consists of post offices, whereas a post office consists of packages. So a nested to nested structure this one is. Here is the implementation of the first function, print all packages. Given a parameter town as a structure variable, sample output should be something like this. The first one, name of the town, followed by one tab here printing the post office details. First post office consists of these many number of packages. Then second post office consists of these many number of details of packages. Then again town B, that is the name of the town here. So the first thing what we need to print is the name of the town, followed by one tab, then followed by two tabs, /t and /t. Keeping these things in mind, let us see the code here. The name of the town is printed. Then we are trying to print the offices. So starting from the 0th office till the office counts, t dot office count. Office count is a member of this structure town. So we are printing here that ID, then followed by here are the packages counts. So for printing the ID we are using 1/t. For printing the packages details we are printing 2/t's. So this print all packages will accomplish the first task. So we have done with the first task of printing it, this one. Let us see the second function in the list. Send all acceptable packages from source town to the target one. Here is the code for the function send all acceptable packages, taking source town as the first parameter and source office index as the second parameter and target town as the third parameter and target office index as the fourth parameter. Taking n as a variable, initializing it to 0, and we are iterating it for the number of offices including all the number of packages. So from 0 to source, whatever is the number of offices are there, source of office, using this source office index dot package count. So this office consists of how many number of packages, we are iterating it. First condition what we are checking here is if the source office package weight is greater than the target office minimum weight and the source office package weight should be less than or equals to the maximum weight of the target office. Then we are incrementing the value of n where n is initialized to 0. Here we are declaring a new variable, new packages and old packages. We are allocating the memory dynamically based upon this n value for new packages, and for old packages we are going to allocate the memory directly by subtracting that particular count value n what we have allocated for new packages. Now where we have to place this one, let us iterate it from 0 index to the target office of number of packages available. So n will contains now the package count of the target office, and at the end use a loop to iterate it for all the offices and all the packages in each office. If the source office index of that package weight is greater than, that's all regarding the function for sending all acceptable packages. So packages are accepted based upon this criteria, what we are checking the condition over here and placing it into new package, otherwise placing it into old package. Coming it to the implementation of the next function, that is town with most number of packages. You will be given all towns. You need to find the most number of packages in all post office altogether. Here is the number of packages. Just need a loop because we have to iterate it for all the number of offices using the count called as office count, and iterate it and add, initialize answer as 0 and add the value of package count into this answer and return that answer as an integer. Very simple. And the next one in the list is town with most packages. Town with most packages means we have to count how many number of packages are there in each town. So here take a variable maximum package, initialize it to -1 and go to each town using town count, and if the number of packages in each town, what is this town is doing, check the condition. If the number of packages of town I is greater than maximum package, immediately replace that one into maximum package and assign I value into answer. Same way repeat it. Whenever you are getting a value greater than maximum package, then immediately replace it and store it in maximum packages. And at the end of this one, return the towns with answer, that is the town with most packages. And here is the last function to implement, find the town. Here you are given 3 parameters, towns, towns count and the name of the count, and the name of the town as the third parameter. Compare towns of I name with the name passed as a parameter. If it matches and returns 0, then negation of 0 will be true, then returns that particular town. And if it doesn't matches, returns the address of town 0. So by seeing these particular functions, let us see the implementation of this one by running the code and checking the output according to the input provided on HackerRank website. Let us run. Let us enter the input according to the input provided on the website of HackerRank. Here, this is the sample input, what we need to enter it. Let us enter according to this one. The first information what we have is number of towns. Number of towns are 2 and the first town is A. Within this one we have 2 post offices and we have the information of this one as like this. The first one minimum weight and maximum weight, and the first one is A with weight 2, second one B with weight 3. Let us have the second post office 1 with minimum 2 and maximum 4 weight, and information here is C, 2. This completes the information of town A. Let us give the information of town B. Town B consists of only one post office, which consists of 4 packages. Minimum weight is, whose minimum weight is 1 and maximum weight is 4, and the IDs are D and minimum and the weight is 1, E whose weight is 2, F whose weight is 3, H whose weight is 4. Here completes the information of town B as well. Now we are having 5 queries here. Among these 5 queries, the first query is 3. 3 means directly print. Here you can see, whenever I am pressing this 3, we are getting the town with the most number of packages is B, because we have town A consists of only 3 packages, whereas town B consists of now 4 packages. Let us run the second query now. Second query is 2. B, we have to shift 1, that is index 0 information to town A with index source this one is the target one. And when we try to print now, you can see town with the most number of packages is A now. Earlier it was B. Let us run the last two. One with A. This is the information regarding A, and this is the information regarding B. A was consisting of A, B, C. B was consisting of D, E, F, H. All these three E, F, H are now shifted to A town such that E, F, H. Earlier the count was 3, now the count became 6. Here earlier the count was 4, now the count became 1. And D is the only one which is left out here, and it is printed here. The information of the first one, AB information, is available here, and the remaining information you can see it in the post office ID 0 and 1. This is the post office 0th information. Successful execution of this code we have seen. Now the thing is, we have to upload this code here. So let us upload the code. I'll remove the redundant data from the file which is available here. So keeping these only 4 functions in the file, I'll remove the remaining things and then upload it. Upload code as file, say yes, select file, select post transition and say OK and say upload. Now that the file has been uploaded, let us run the code and check. Yes, congratulations, sample test case has been cleared. You have passed the sample test case, and let us submit the code. Fetching the result here. Congratulations, you have solved this challenge and we have earned 50 points. You can see with this one we have done almost 24 challenges and we are now under the rank of 3000 with 560 points. Hope the working of this challenge is clear. We will see the next challenge, that is the left out challenge, in the coming videos. Thank you. Hi and welcome to another online coding challenge on HackerRank. Today's problem is structuring the document. This problem we have already solved using pointers with a name, querying the document. So those who have not seen that video of querying the document, I first of all strongly recommend you to go through that video first, see how exactly the problem is solved, because the problem definition is the same. Only difference in this problem is the approach. Here we need to take a structure, so the concept of structures are considered here to solve this problem. Problem definition remains the same. So I am not going to repeat the explanation of the concepts what we have seen in this querying the document. So those who have not seen the video, they can see this challenge first, querying the document, then you can later on solve this one. And the problem definition, I'll quickly recollect it. A document is represented as a collection of paragraphs. Paragraph is represented as a collection of sentences. Sentence is represented as collection of words, and a word is represented as a collection of lowercase a to z and uppercase a to z English characters. You will convert a raw text document into its component paragraphs, sentences and words. To test your results, queries will ask you to return specific paragraph, sentence or word as described below. So Alicia is studying the C programming and she has that problem of representation of words, sentences and paragraphs and documents using pointers. So sentence is described here in the form of a structure, something like this. Data, which is a one-dimension array, and the number of words what we have in a sentence is specified by this word count, total number of words in a sentence. The words in a sentence are separated by space. Remember this point. Every word is separated by a space. The last word does not end with a space. Whereas paragraphs, we have collection of sentences where every sentence terminates with a dot, whereas the last sentence does not terminate. Same thing, a document is a collection of paragraphs here we can see data is now going to be a one dimension array of paragraph type, data is a one dimension array of sentence type, there data is a one dimension array of word type. Same thing what we need to do it here. So these are the functions what we need to implement it. Only thing what we need to do here is we need to understand how exactly structures works. Let us quickly go to the program now. Here is the program. We required kth word in mth sentence of nth paragraph. If you remember, same thing what we have done it using pointers over there. Now data is a data member of every structure, but main structure what we have is a document. So document is a variable using which we are now going to call this data dot this data dot this data. So this is going to be the kth word of mth sentence of nth paragraph. Same way, kth sentence or in mth paragraph. This is going to be the kth sentence in mth paragraph, and kth paragraph what we need to return from a document is going to be data of k-1. This is already implemented. We need not worry about this printing of word and printing of sentences. And here is a method what we need to implement is get document. If you remember, we have already done this one. Every document consists of or collection of paragraphs. Every paragraph terminates with /n. So here whenever we encountered /n, we are incrementing the paragraph count. Here only thing what we need to remember is when we are implementing structures, structure variable whatever we have, structure variable for document dot paragraph count. So dot is the operator what we are going to implement it. Same thing, calloc is used to allocate the memory there also. Here also we are using the same calloc function. Same thing, we are using /n to check whether a paragraph ends or not. Whenever a paragraph is terminated, we are calling get paragraph function. If you remember, there also we called get paragraph function with starting the text from the paragraph and starting index and the ending index. And what exactly get paragraph function is? And here is the get paragraph function. Every paragraph consists of collection of sentences where every sentence terminates with a dot. So whenever we encounter a dot, we are incrementing the sentence count. Based upon these number of sentences, we are allocating the memory dynamically, and starting index to ending index we are calling get sentence. Get sentence is a function called within get paragraph. Get paragraph is a function called within get document. So starting index, that is the beginning index, add to the ending one, returning the answer. Let us see now get sentence. Here is the function get sentence. Every sentence is a collection of words where words are separated with a space. So whenever a space is encountered, we are incrementing the word. Total number of words whenever we are getting, allocating the memory dynamically using the number of words, and calling another function get word for the following text starting index to the ending index. And here is the last function that is there, get word. Get word for the text beginning index, ending index, and allocating the memory based upon this range, that is a size. And here is the text what we are placing it into this array, data array, and we are returning that answer. Let us see the implementation of this one. As there are no errors, we will run. We will give the input in the following way. Two paragraphs. The first paragraph, learning C is fun, and the second paragraph consists of two sentences. Learning pointers is more fun. It is good to have pointers. When I enter 3 and the input value that is 1 to 2, I'll get the output as learning pointers is more fun. It is good to have 2 pointers. That is 2 sentences. We have extracted it. And for the last input value 3, when I say 1, 1 and 1. Okay, we missed one input. So 2, 1, 1. When I say learning C is fun. Yes, perfect. For this is going to be the output. For this is going to be the output. And for the middle one, what we have given at the end, this is going to be the output in the middle. That is perfect. Now, let us upload the code file. Say yes, select file, structuring the document, select the file, open and say upload. I'll remove the redundant data. Till here it's already there. So main function is also there. Print paragraph, print document is also there. Okay, we have uploaded the file. Then let us run the code and check. Congratulations, it has passed the sample test cases. Perfect. Let us submit the code. Going through the test cases, and here is the compiler message. Congrats, you just solved all the structures and enum challenges in C language, and we have earned 60 points and 100% is done with this. You can see now here 25 out of 25 challenges we have solved, and here is the rank. What we have is first rank, and the number of points what we gain is 620 by solving 25 challenges, and this is the last one among all the 25 challenges. So we have successfully solved all the challenges of the HackerRank site. That's all regarding these challenges. If we have anything further, we will see in the coming videos. Thank you. Hi, in this section we will learn about the following. First, we will have the introduction part of files. Then we will see why files are needed. Then what is a file in C language, and at the end we will see some basic operations on files in C language. Let us begin with the introduction part of files. Why there is a need of files and what do you mean by files? Till now, whatever programs we have seen, those programs takes input from keyboard, stores in a variable or array, then uses the data and display, or process the data and then display. Whatever data we use it using variables and arrays is temporary. That is, as soon as the program terminates, then we will lose that information. So here, storage of data in variables and arrays is temporary, such that it is lost when a program terminates. Now here comes files, which are used for permanent retention of data. If you want to retain the data which is used while running the program, so whatever data we have used while running the program, that data can be preserved in the form of files. Computers stores files on secondary storage devices, especially called as disk storage devices. The memory what we use it while running the program is random access memory, whereas if you want to permanently store the data, then that data is stored on secondary storage devices, something referred to be as disk or hard disk. Why files are needed? Let's see here. When a program is terminated, as we have just now discussed, that once the program gets terminated, whatever data that is used with that program will be lost. Now, storing in a file will preserve your data even if the program terminates, so that we can use the data later also. If we have to enter a large number of data elements while giving input from keyboard, when the program is running under execution phase, then obviously it will take a lot of time to enter the data through keyboard. But if the same information is stored in the form of files, then we can easily access the contents of the file using some commands. Then what are those commands are? We will see those commands in the coming sections. Using files, we can easily move the data from one computer to another computer without making any changes. That means that whatever data we have preserved in the form of files, we can easily move it from one computer to another computer or from one storage device to another storage device. Here is what exactly a file is. A file represents a sequence of bytes. As we know that the basic information what computer stores is zeros and ones, that is bits. Collection of 8 bits is nothing but a byte. Whatever information we have to store either in the form of integer, character, float, double or any data type, then computer uses the memory location in the form of bytes on the disk where a group of related data is stored. In other words, a file is a container in computer storage devices used for storing the data. So it acts as a container in computer storage devices which preserves the data for the later use. File is created for permanent storage of data. Now it is a ready-made structure. Just you need to provide the extension of a file, then the file will be created for you. As you enter the data, the size of that file will get increases in the form of bytes. In C language, we use a structure pointer of file type to declare a file. In the coming sections, we will see how to declare a file pointer and how to open a file, how to access the contents of the file and so on. And at the end, let us see some basic operations on files. Obviously, before performing any operation, we have to create a file. If it is already existing, then we can open an existing file as well. Then once we have done with creation or opening an existing file, then we can perform the operations, something referred to be as reading from a file and writing to a file. Then we can move to a specific location in a file such that we can access the data from any desired location in a file. We have some advanced functions provided by C language in the form of seek and tell, such that we can make use of these functions and access the contents of the file dynamically or randomly. Then at the end, the operation performed is closing a file. So any file, first of all, we have to open it if it is already existing. Otherwise, we have to create a new file. Once we are done with this one, then we can perform reading and writing operation on it. There are two methods of accessing the contents of a file. One is sequential access, another one is a random access. Once we come to the advanced topics of files, we will look into those operations. So for time being, these are the basic operations on files, and this is just an introduction part of files. The remaining topics we will see in the coming videos. Thank you. Hi. In this section, we will learn about the following. What is a stream? What are input and output streams? How to use file structure? And at the end, what are the standard library functions supported by C language? Let us begin with understanding what do we mean by stream. A stream is nothing but collection of zeros and ones, that is bits. We call that one as collection of bytes is nothing but a stream. So C views each file simply as a sequential stream of bytes. Say for example, if we have n number of bytes to be stored in a file, then that can be seen here as follows. Each byte is occupying some memory location over here with 0 to n minus 1 followed by end of file marker. That means that every file will have a termination point where we should stop reading the contents of the file, something referred to be as end of file marker. So a stream is nothing but a collection of bytes placed sequentially in the memory, and at the end we will be having a end of file marker. Now, as we have seen that each file ends with a end of file marker, we usually call it as EOF, end of file marker. Now, when a file is opened, a stream is associated with that file. It is just like a pipe which connects a program and the storage device. One end of the pipe is connected to a program which provides or reads the data. The other end of the pipe, that is a stream, is connected with the storage device where the data is stored or is to be returned. Three files and their associated streams are automatically opened when program execution begins. These three are, first one is the standard input stream, another one is standard output stream, and the third one is standard error stream. Whenever we want to read the data, we will be using standard input stream, that is std in C language, and for standard output we will be using std out, and stderr is used for standard error streams. Let us see what are the input and output streams are. Streams provide communication channel between the files and the programs. Just now what I said, that it acts as a pipe between the files stored on a storage device and the programs. Example, the standard input stream enables a program to read the data from the keyboard, and the standard output stream enables a program to print or write the data on the screen. So we have std_in and std_out as the input and output streams provided by C language. Let us see what exactly a file structure is. Opening a file returns a file pointer to a file structure. That is, whenever we open a file, then we will be having a pointer using which we can access the contents of the file. This file structure is defined in stdio.h. That means that whenever we want to access this file structure, we have to include stdio.h header file in our program. This contains information used to process the file. This structure includes a file descriptor, that is an index, into an operating system array called open file table. The operating system maintains an array which is referred as open file table, which stores the contents of the file details and which can access using the file descriptor. Each element of the array contains a file control block that the operating system uses to administer a particular file. The standard input and standard output and standard error are implemented using these file pointers, that is std_in, std_out and stderr. We will be seeing the program demonstration to demonstrate these standard input, output and standard error file pointers. At the end of this section, let us see some standard library functions. The standard library provides many functions for reading the data from files and for writing the data into the file. Like to read the data from keyboard, we can use scanf, getas, getchar, getch are the standard functions for reading from the keyboard. Similarly, for printing the data into the monitor, that is console, we have printf, puts and putchar function. Similar to that one, we have some standard functions for reading and writing the data from file. One of them is a function fgetC. It is same as getChar function, which reads one character at a time from a file. Like getChar function reads a character from keyboard, fgetC reads a character from a file. Function fgetC receives as an argument a file pointer for the file from which a character will be read. So fgetC will have one file pointer variable using which we can read a character from the file. The call fgetC with stdin parameter reads one character from stdin, that is the standard input. This call is equivalent to the call getChar. Reading one character from keyboard is getChar. Reading one character from file is fgetC. So both are equivalent. Then we have fputC, similar to putChar function, which is used for writing a character into the monitor, whereas fputC is used for writing one character into a file. Function fputC receives as arguments a character to be returned and a pointer for the file to which the character will be returned. The function call fputC with one character as a parameter and stdout writes the character A to stdout, that is standard output. This call is similar to putChar function, that is printing a character into the console. Several other functions used to read data from standard input and write the data to standard output have similarly named file processing functions. Among them, some are fgetS to read a string from a file, fputS to write a string into a file, fscanf is to read the data from a file, fprintf is to write the contents into the file. We have some other functions like fread and fwrite also to be included into standard library functions that we will see in the later part of the file sections. That's all for now. We will see the remaining topics in the coming videos. Thank you. Hi, in this section we will see what are the different types of files are there in C language. Here in this section we'll start with first how many types of files C language supports, then some details about text form of files and some details about binary form of files, and at the end we will see how data is stored in both the forms of files, that is text as well as binary files in C language. Let us begin with understanding how many types of files are supported by C language. When we deal with files, we must know about the following types of files in C language, and these two are, first one is a text file and the second one is binary files. With this name itself, we can easily make it out what type of information text file can store and what type of information binary files stores, or if we give the input to a text file, in what form or what format the text file is going to store the data and what format in which binary files can store the data. Text files are normal .txt files. We can easily create a text file using any simple editors such as Notepad, WordPad or any other text editor. The extension of such files are .txt. When we open these files, we will see all the contents within the file as plain text. It is very easy for us to perform these operations on text files, that is inserting the contents, modifying the existing contents or editing the contents, or delete the existing contents in a file. They take minimum effort to maintain and are easily readable and provide the least security and takes bigger storage space. So the advantage of having text files is maintenance is very minimum or very easy to maintain and very easy for reading. Let us have the second form of files, that is binary files. As the name itself indicates that binary files can store the information in the form of zeros and ones. Binary files are generally uses .bin extension in our computers. As a replacement for storing data in plain text, they store it in the binary format, that is using zeros and ones. They can hold a higher amount of data as zeros and ones occupies less amount of memory and are not readable easily, that is they are not user friendly for reading the contents as the data is stored in the form of bits and bytes. So a user finds it's really difficult when compared to text file, but this form of files provides better security than the text files. At the end of this section, we will see how the data is going to be stored in text files and how the data is going to be stored in binary files. First, we will start with text files. Text file stores the data as a sequence of characters, and each character's ASCII value is calculated and then converted into its binary equivalent, whereas binary files stores the information by converting the data directly into its binary equivalent. So here in this form of files, that is binary files, the data that is there will be directly converted into its binary equivalent. Let us see with an example how exactly the data is stored in both the forms of files in C language, that is in text files as well as in binary files. We have two data types. One is short int, assumed to take some value, say 768, and a character, say character uppercase A. If these values are stored together in text file, then individual numbers, that is one number, that is say 7, is assumed to be one character. Let us see here first in the form of text file. Each number, that is a digit, is assumed to be one character. Then 7 will not be directly stored as its binary equivalent, but 7's ASCII value will be calculated first, then its ASCII value is converted into its binary equivalent, which will be stored here. ASCII value of 7 is 55. Let's see how 55 is converted into its binary equivalent. The rightmost digit, that is 1, equivalent is 2 to the power 0 plus next digit is 2 to the power 1, next digit is 2 to the power 2, next digit is 0, so we will not consider that one. Next one is 2 to the power 4, and the last one is 2 to the power 5. Which one is here? This is 2 power 5. Then from here we will calculate it as 2 power 5 is 32 plus 2 power 4 is 16 and 2 power 2 is 4 and 2 power 1 is 2 and 2 power 0 is 1. If you sum up all these values, you will get 55. Then comes to the next one. 6 is assumed to be another character whose ASCII value is 54. And the same form of conversion will be there here. It will be something like this: 2 power 1 for this one, then 2 power 2 for this one, then 2 power 4 for this one, and 2 power 5 for this one. That will give you a total of 54. Finally, we have the last character in this one is 8, whose ASCII value is 56, and same conversion it will be done and it will result it into 56. And then comes, say, character A. While storing character A, its ASCII value is 65. So character A ASCII value is now going to be 65. So it's now going to give you 2 power 6 plus 2 power 0, which will give you 2 power 6 is nothing but 64 plus 2 power 0 is nothing but 1, which will give you 65. If the same information is stored in the form of binary files, let's see here. The main difference comes here. 768 is treated as a single number and its ASCII value will be calculated. Let's see how this one is converted into its binary equivalent. If you see from right to left, all these are zeros, that is from 2 to the power 0 to 2 to the power 7, all are zeros, whereas the first digit that comes 1 is for 2 to the power 8 and the next one that comes is for 2 to the power 9. If we take these values, it will be 512 plus 256, that gives you 768. That is how this binary equivalent 768 is converted into its binary equivalent and stored in a binary file. And character A, the same conversion. Here it is 2 to the power 6 and here it is going to be 2 to the power 0. Sum of this value will give you this 65 here. So this is regarding how the data is going to be stored in text files and binary files. We can see the advantage easily of using binary files. As conversion is not done in case of binary files, accessibility is faster and security of data is also high when compared to text files. That's all regarding types of files. We will see the remaining topics in the coming videos. Thank you. Hi. In this section, we will see how do we declare a file pointer and how do we open a file, followed by how many types of file opening modes are supported by C language and the details about each file opening mode, and at the end, how do we close a file. In the earlier videos of files, which covers introduction part to files and how many types of files are there, then we have seen files and streams and how many types of files are there in C language. Here, let us begin with understanding the topic of declaring a file pointer. When working with files, the first thing what we need to do is to declare a pointer of type file. This declaration is needed for communication between the file and the program. Syntax for declaring a file pointer. File is a keyword with all uppercases followed by star and the file pointer. Example, file star fp is a file pointer which can be used to communicate between file and the program. Let us see how we can open a file. Obviously, before performing any operation on a file, it has to be open. Opening a file is performed using the function fopen. Fopen takes two parameters. One is the file path along with the file name, followed by the mode in which the file has to be open. Both the parameters are of string type. This function is defined in the header file stdio. So whenever we are making use of this function fopen, we should make sure that we should include stdio.h. Here is the syntax for opening a file. Fopen takes two parameters, that is file to be open with the complete path, followed by the mode in which the file has to be open. It returns the address which is stored in a file pointer, which is of pointer type. Let us see how many number of modes in which we can open a file. Here are the list of modes in which we can open both the types of files. That is, there are 6 modes to open a text file, and followed by the remaining 6 modes for opening a binary file. First one, let us start with the first one, R. R mode specifies to open a file for reading purpose. Here make sure that the file should exist in the location what we are specifying as the first parameter. So open an existing file for reading. If the file does not exist, it returns a null value. Then the second mode is W. W is used for creating a file for writing purpose. And here, if the file is already existing, it will remove the current contents of the file or override the existing contents. Let us say, if the file is not existing, then W will create a new file and write the contents into it. As you can see, there is a drawback with W. That means that every time you open a file with W, it will overwrite the contents. To overcome this drawback, we have the third mode, that is append. Appending in the sense, whatever the current contents of the file is there, it will keep those contents intact as it is. Then the file will be added to the existing contents. Here you can see, open or creates a file for writing at the end of the file. Then we have 3 more versions of R, W and A, that is R plus, W plus and A plus here. The first one, R plus. Open an existing file for update, that is for both. Actually it is meant for opening for reading purpose, but we can perform write operation as well. W plus, and one more thing, for R plus the file must exist, whereas for W plus, if the file is not existing, it will create a new file and meant for updation purpose. If the file is already existing, whatever contents are there, it will be overwritten. That means that the current contents will be lost. A plus now appends, open or create a file for update. Writing is done at the end of the file. These 6 operations, that is R, W, A, R plus, W plus and A plus, are meant for text files, whereas the remaining 6 operations, that is, you can see clearly here B with all the modes, that is RB for R, equivalent of R in text mode. Similarly WB, AB, RB plus, WB plus and AB plus. Same operations with respect to binary files. So these are the modes in which a file can be opened in C language. Now let us see how we can perform read, write and append operations on the following modes. Now let us see what we can do with these particular modes. The first one, R. If it is R, that means that it is meant for reading purpose. W is meant for writing purpose. A, that is append, is again writing the contents at the end of the file, that is nothing but adding the contents at the end of the file. R plus, basically it is meant for reading purpose. W plus for writing purpose, as well as you can read the contents as well. A plus meant for basically writing purpose. Here, if a file is open in R mode, can we read the contents? Yes, we can read the contents, but you cannot write or you cannot append. Yes, you can read here in R plus, even in W plus, you can see it very clearly here. You cannot perform read operation with W, whereas you can perform read operation with W plus as well as A plus. Now comes to write operation. If a file is open with R mode, you can perform write operation with the remaining all set of modes. Same way, append. If it is open in read mode, you cannot append the contents. Even in W also you cannot append, whereas you can append the contents only if it is A or if it is A plus. Now, if the file is open in read mode, is it compulsion that the file must exist? Yes. When the file exists, then only you can open it in read mode. But here it is not compulsion. If the file does not exist also, a new file will be created. Here also it is not a compulsion that file must exist, but here also it is a compulsion. That means that it is mandatory for R and R plus mode that the file must exist. Otherwise, it is not mandatory for the remaining modes. And the last one, if the file is open in read mode, the contents of the file is lost. No, because we are not performing any updation. But here, as we are performing write operation, there is always a chance of the existing file data will be lost. And if the file is open in append mode, the contents of the existing file will not lost, as the contents will be appended at the end. Here, if it is open in R plus also, the contents of the existing file will not get lost, whereas in W and W plus, two modes, you will get the existing contents files will be lost. So make sure that what is our requirement. Are we going to perform only read operation? Then go for R mode. And if you are going to perform any updations to the existing contents, appropriately we can choose the mode and open a file. So choose the mode appropriately where it is required. Applications which required only the data to be read, the file can be open in read mode. If you are not very much bothered about the current contents, then you can go for W or W plus. If you want to keep the current contents intact as it is, then we can go for either A or A plus mode. The same thing are applicable for binary files also, that is with RB, WB, AB, RB plus, WB plus and AB plus as well. That's all for now. We will see the remaining topics in the coming videos. Thank you. Hi and welcome to the demonstration session of files. Here in this program, we will demonstrate how exactly a file can be open for reading purpose and how a file can be open for writing purpose. In the same program, we will demonstrate both the modes of opening a file, that is read mode as well as write mode. First thing what we need to do is declare a file pointer. A file pointer is used to access the contents of a file. A file can be opened in read mode, write mode, append mode, that is R, W and A, as well as R plus, W plus and A plus, both for text as well as for binary files. By default, if we just specify W, here means it is a text file. For binary file, B will be used. That we will see in a separate video. Here we are trying to open a file with a name called as testing.txt. It is a text file and the mode specified over here is a write mode, and the path of the file is to be located in C colon, that is in C drive. fopen is a function used to open a file which takes two parameters. One is the path of the file along with the file name, and second one is the mode in which the file is to be open. Both are specified using double quotation mark. That means that both the parameters of fopen are of string type. fopen, once it is opened successfully, then a file pointer is going to take the address of that particular file. When we are using W mode, it checks whether the file is existing or not. If the file is existing, it will open the current file and rewrite the contents. Otherwise, if the file is not existing, then W mode will open a new file and a file pointer can access the contents of the file. In case if the file pointer is holding null value, then give a error message and exit. Let us say if the file has opened successfully, then you are giving a message to the user to enter a number, reading the number, and here we are making use of one statement fprintf to write the contents into the file. Now which file? This file testing.txt is accessible with a file pointer called as fptr, which is declared over here. fptr is a file pointer for testing.txt. We are writing this number into this particular file. Once it is done, we are closing the file and then we are opening the file again in read mode. Now for read mode, the file should exist. If it is not existing, then it will give a error message. That means that within if condition, we are checking the file pointer value. If it is null, then error message is given to the user and terminate the program. Let us assume that file has opened successfully. We are reading the contents from the file using fscanf function, which takes two parameters. One is a file pointer, another one is the value to be read from the file. Value we are reading is of type integer, that's why %d is specified. This function is similar to scanf, which reads the contents from keyboard, and f over here specify we are reading the contents from a file specified by the file pointer. Once we read the data into this variable, we are printing the same value into the console to just confirm what we have read. Once it is done, the file is again closed using a file pointer. Let us build, check for the errors. No errors, no warnings. Run. Enter a number. I'll enter say 550. You are getting a message over here. Value of n from file is 550. Let us see in the disk, is the file testing.txt exist? Here in C colon, testing.txt is there. I am opening this one in a notepad, and the value what we have entered from the console, that is 550, is available here. I'll repeat once again. Before performing any operation, we have to declare a file pointer. Then fopen function is used to open a file. We are writing the contents, so write mode we are opening. And if file pointer contains null value, giving error message and terminating the program. Otherwise, the number entered by the user is returned into a file using a file pointer, and the file is closed. And again the file is open in a read mode, checking if it contains null value, giving error message to the user and terminating the program. Otherwise, reading the contents from the file using a file pointer and displaying the same to the user. And at the end, don't forget to close the file using a file pointer. This is just a introduction part to the file and file operations, that is fopen and fclose. That's all for now. We will see the remaining topics in the coming videos. Thank you. Hi. In this section, we will learn about the following. There are different types of file functions provided by C language. So we will categorize it into different categories over here. The first one among them is the formatted input and output functions. Next one in the list is the character input and output functions. Then we have direct input and output functions used for binary types of files. And there are some advanced file positioning functions like fseek, ftell and rewind. We will see those functions in this category, that is file positioning functions. And there are some error functions provided by C language. We will see those error functions at the end of this section. Let us begin with the first one, that is the formatted input and output functions. We already came across these one. That is, first one is reading from a text file, fscanf. Simply, scanf means reading the contents from a keyboard, whereas fscanf reading the contents from a file. Syntax for this one is a file pointer is the first parameter, followed by the character array. Same thing, we have getS function for reading a string from a keyboard. Now here the syntax changes. File pointer is placed as the last parameter over here, and there is a second parameter called as the size. How much size of string you are going to read it from a file, that we have to specify as the second parameter. And the first parameter is a character array. So a character pointer is the first parameter. Similarly, writing the contents into a text file, printf normally used for printing the contents into the monitor. Here fprintf is used for writing the contents into a file using a file pointer as the first parameter. Similar to puts function, which is used for writing a string, here fputs is used for writing a complete line, which is used as a first parameter, and file pointer is the second parameter. Both these operations, that is fscanf, fprintf, fgetS and fputs, are used to perform on a text file. We have already gone through the types of files in C language. There are two types of files are there. One is text file, another one is a binary file. Let us see the next category of functions, that is character input and output functions. We want to read a character from a file, one character at a time. Generally, when we say getC is used for reading a character. When we add f to this function, it becomes fgetC is used to read a character from a file using a file pointer. It returns a single character. Writing a character into a file, fputs, whatever character we want to write it into a file is the first parameter, and the file pointer is used to specify the address or the file in which we want to write this character. Again, this one is also done on a text file. Here is the third category of functions, which are something referred to be as direct input and output functions. The name direct came because we are going to perform the direct operations in the form of bits, that is zeros and ones, using binary files. Here is how do we write into a binary file. We have a function called as fwrite, which takes 4 parameters. First one is a array pointer, which returns void, and the next one is the size and maximum how many number of objects we want to write into a file, and the last parameter is a file pointer, which specifies the location of the file along with the file name. Here is an example to understand how exactly we used to perform fwrite operation. Here you can see this is a file marker which is assumed to be marking into this particular memory location before performing write operation. Let us say if I am performing, say the size of each block is assumed to be say 4 bytes, and we are considering it 3 such blocks. Over here 4 multiplied by 3, totally 12 bytes, we are going to perform a write operation. So before writing the contents, the file pointer was here. After performing write operation, that is the first block of 4 bytes, next block of 4 bytes, and the next third block of 4 bytes. We can clearly see after performing this write operation, the file marker is now placed over here. This is how a fwrite operation is carried out. Let us see how do we perform a write operation using a structure. Let us say each structure is of this much size. We want to write a structure, so a file marker, that is a file pointer, is currently pointing it to this particular location. The situation before performing write operation is this one. We want to perform a write of this block. So here after performing it, that is we have placed this block here such that the file marker was earlier here, now has moved into this particular location. These are individual structures. We have written this particular structure using fwrite operation. So this is the scenario before performing write, and this is the scenario after performing write operation. Remember, this is operation on a binary file. Let us see how we can perform reading of data from a binary file. We use a function called as fread function. Fread takes again 4 parameters: pointer of void type, size, and the maximum number of objects. Last one is a file pointer. Here is how we perform a read operation. Say we want to perform a read. So file marker, let us say it's pointing it over here before performing read operation. I want to read the contents. So how many such blocks we want to read? Say for example 3 blocks. 3 blocks of 4 bytes each. 4 bytes each. I am going to perform such 3 numbers. So here size is going to specify over here as 4. Maximum number of objects how many we are going to read it is 3. So there are going to be 12 bytes what we are reading it. Once we have performed a read operation, the file marker will move from this position to this position. This will give you a clear picture how exactly a read operation is performed. Say for example, instead of using 3 over here, if we would have used 2, then obviously the file marker, that is, will be placed over here after reading 2 such memory blocks. Let us now see how do we perform a operation of reading a structure. Here is a file pointer. File pointer is now pointing it to a structure. Before performing a read operation, file marker is now here. When we perform read operation, nothing is there. We have read. Now after performing read operation, a structure contains multiple data types. So it can be an array of character, an array of integer, a normal variable of character type or integer type maybe. Same structures are repeated over here. Once we are done reading a structure, this one that we have read it over here, then the file marker has moved from here to this particular memory location. Now it is pointing it to the beginning of the next structure in the list. Now we will see file positioning functions. First one among the file positioning function is fseek. Syntax for this one is, it takes 3 parameters, file pointer as the first parameter, offset is the second parameter, that is the size, and the origin. We have 3 types of origins provided by fseek function that we will see it here. These are the 3 different categories of origins provided by fseek. The first one is seek underscore set. Seek underscore set starts the offset from the beginning of the file. That means that it starts the offset from the beginning of the file. Next one, seek end. You want to perform reading or performing any operation from the end of the file, then seek end will be the origin to be used. And the third one provided is seek underscore cur, that is the current. Starts the offset from the current location of the cursor. What exactly the file position pointer is pointing it, it will start the offset from there. With an example, we will see how exactly this is going to be. Let us see here. Assume that the initial state of a file is here. This one is a file pointer pointing it to the beginning of the file. This one is the end of file marker. We refer this one as EOF, that is end of file pointer. Let us say if I am calling fseek with these 3 parameters. First one is a file pointer and next one is the offset, that exactly is the size. Say 4 blocks I want to move, but I don't know the size of the structure. That's why I am calling size of operator, which takes one parameter of structure type. So earlier the file pointer was here. Now I am saying fseek 4 times the size of the structure, that is seek set, that is 1 block, 2 block, 3 blocks and 4 blocks of such size of structures. It has moved the file pointer from this position to this particular position. Let us say how to move from the end. We have seen that seek underscore set starts from the beginning, that is from the starting. So here this one is now going to start from the beginning, whereas this is going to start from the end of the file. here is, when we are starting from the end of the file, we have to give offset in minus. That means that if we assume that the file pointer is at the end, and this is going to be the first structure, this is going to be the second one, this one is going to be the third one, and here is the fourth structure. For such a structure, we don't know the size of the structure. It can be one character, one array, one integer, all together. How much exactly the size of the structure, that will be calculated by size of operator. File pointer, so it has taken a file pointer, file position from this position over here, -4, and CUR here specifies it is current position, from current position onwards. So this one is going to say the current position. Let us assume that from here onwards, currently the file pointer is here. When we set 2 times the size of the structure, 1 and then 2, it has moved from here in the forward direction. Remember, seek end is the only one origin using which we can move into the reverse direction, whereas both seek underscore set as well as seek underscore current will move the file pointer in the forward direction of the files. So here, since it is two structures, it has moved a file pointer. Hope with this example the concept of fseek is clear. We will see in an example how this fseek function works. The next file positioning function is ftell, which tells you the current location. Ftell returns the current location in the form of number of bytes. Say for example, here is a file position or file pointer which is pointing it. So we have traversed how many number of bytes to reach that location. Say for example, here we assume that this block is of 4 bytes, this block is of 4 bytes, this block is of 4 bytes, and this block is of 4 bytes. All together you will get a total of 16 bytes. So current location, it will show you where exactly the file pointer is. From the beginning of the file to the current location, how many number of bytes. Again, we will see this one also in an example program. And the third one is rewind. Rewind will just make the file pointer to be reset to the beginning of the file, wherever the file marker is. Say for example, the file marker or file pointer is currently pointing it into this memory location. Before performing rewind step, immediately after performing rewind step, we can see the file pointer is now pointing it to the beginning of the file. After performing rewind operation, let it be wherever the file pointer is. Let it be at the end, let it be in the middle, or wherever it is. It will directly move the position of the file pointer to the beginning of the file. As the name itself specifies, rewind makes a pointer to place at the beginning of the file. At the end of this section, we will look at what exactly the file error functions are there. Here is the first one, clear error. Returns void using a file pointer. Whatever errors we are going to display, that will be getting cleared. And the next one is FEOF. That is, it returns a non-zero value when end of file is reached and returns 0 if end of file is not reached. When a file pointer has reached end of file marker, then this one will be a non-zero value. So integer it is, otherwise 0 is returned. Ferror returns the error, a non-zero value if there is error, otherwise 0 will be returned. Printing the error, whatever the file opening error is there. Say for example, while opening a file we get some errors. You want to know what type of error it is, then you can print that error using a character array. Now let us see the demonstration of the file positioning functions. Here is a program. We are trying to read from a file in read mode, which is located somewhere in C colon. If file pointer returns a null value, then we are giving a message to the user unable to open and terminating the program. Let us say if it has successfully opened the file, and using that file pointer we are reading character by character using fgetC function until we reach end of file. That character whatever is read, we are printing the value into the monitor. After the completion of this while loop, the file pointer is now pointing it to the end of file. That's why we are making use of this function again, rewind, to make the file pointer to point it again to the beginning of the file. Now here, read again character by character and tell what exactly the position is using ftell function. Printing that character again and waiting for the user to enter a character and then continue the loop until you reach the end of file. At the end, we are closing the file over here. Let's see what exactly the output of this one is. Let's build and run the file. Here is the original text that is available in the file. Hello and welcome to advanced file operations. First of all, let us see in C colon that file test.txt and open and check the contents of it. Here are the contents. Hello and welcome to advanced file operations available in test.txt file. Now, when we are running this program and ftell is giving you the position of the characters, the first character in this file is h. So here when I am entering it, getChar function is used to read this character, and the second character in the text is e, so on. Ftell is returning that positions over here. We can check. L is the third position, again L is the fourth position, next O is the fifth position. At sixth position there is a space, so on. We can clearly match the contents over here. A, currently the file pointer is here as I am marking with a mouse pointer. Next file pointer is at N, next file pointer is at D, next file pointer is at space, and so on. You can check all these characters. At the end of the file, when we reach EOF, it returns 0. So there are total of 46 characters in this particular file. Once it has reached end of file, we stop the process. So here is the program to demonstrate the working of file positioning functions in C language. Hope this program gives you an idea how exactly file positioning functions are used. We will see the remaining topics in the coming videos. Thank you. Hi and welcome to another programming challenge using files. Here the problem statement of this programming challenge is: write a program to open an existing file and add the information at the end of the file. Display the contents before and after appending the text. Here is some solution guidelines. Say we have a file with some name. Say already this one contains some text. Assume that this file is located somewhere in C drive. The task of this particular programming challenge is to open this existing file and add your contents at the end of this particular file and display the contents before appending what are the contents and after appending what are the contents. Here at this point of time, I suggest you to pause the video and pen down the logic and recollect the concepts what we have learned during learning the concepts of files. We came across already the modes in which we can open a file. Here, the mode in which we required to open a file is A+, because we need to add the contents at the end of the file using, that is nothing but appending using A mode, and simultaneously we have to read the contents of the file which has been modified. Those who have not seen the concepts of files, I suggest you to first go through those videos and learn the basics of files and see the modes in which a file can be opened. Okay, with this particular information, I hope you can write down the program. Those who want to continue with the programming challenge, let us continue now. First thing is, what are the requirements over here? The requirement is, first one, the file must be exist at some memory location. If we are unable to open a file, then a null value will be returned. So check if the pointer stores null value, then that means that file does not exist. Then give an error message and terminate the program. The next step is, what are the existing contents of the file is there? You display the same contents, that is here. Before appending, this is the second task. And the next task is read the data from the user, and next task is to append the contents. You can append the content using this particular mode, append mode, but that doesn't support you to read the contents back. So let us prefer A+ mode such that we can append the contents as well as at the end this operation. We have to display the content after appending. So here is the fifth operation, that is after appending we have to again display the contents. Displaying the contents, that is before, and displaying the contents after appending. So keeping this solution guidelines in mind, let us write a program which accomplish this particular task. Let us start by declaring the required variables. I required a string in which I'll be reading the contents from the user. Then I required a file pointer. Say file pointer is fp. Let us open the file. Fp equals to, let us call fopen function. Give the complete path where exactly the file is located. Let us say I'm giving the file name as say new.txt, assuming that this file is already existing. And the second parameter is the mode in which the file has to be opened. Just now we have discussed, let us open the file in A+ mode such that we can append the contents as well as read the same contents back. Now if you are unable to open this file, then fp will be storing null value. If fp equals to null, we cannot proceed further. So give a message. When fp contains null value, we are giving a message to the user that unable to open the file. Wait for the user to enter a character and then terminating the program using exit of 0. Whenever we use exit of 0, we have to include stdlib.h. Now once we have opened the file, immediately the next task is print the contents of the files what are currently available. So I am giving the message that before appending, the contents of the file are. Now we have to print the contents character by character. That means that I have to iterate it. To iterate it, I am using a while loop until I reach end of file. So I'll say feof function, file end of file pointer. File pointer is the parameter. We have to iterate it and read character. This character we have to declare it over here. So I'll declare a character and we will use this character over here. To read a character, we have a function called as fgetc. Fgetc read a character from the file pointer. Once we got that particular character, then you can display the contents using putchar function. Putchar function takes one parameter, that is character. So reading the contents from the file and displaying it to the user, character by character, until we reach end of file. This loop will continue. This task is done, that is printing the data, displaying the data before appending the contents. Now comes the task of reading the contents. So give a message to the user, enter some text for appending. User will be entering some text here. So let's read it in an array what we have declared it, that is A array. Once we got the contents in an array A, print it using fprintf function in the file. Fprintf function takes three parameters. First one is the file pointer, and second one is the format specifier. What is the format specifier here? %s, and the contents are available in an array A. Now once we have returned into the file, let's display it to the user. Last task is to display the contents to the user. Contents after appending. Now the thing is, we have performed these tasks right now. That means we have opened the existing file. If we are unable to open the file, giving a message to the user and terminating the program, and we are displaying the contents character by character, reading the text from the user, and writing the contents or appending the contents into the file using a file pointer. Now we are trying to display the contents after appending it, but the file pointer will not be there at the top of the file. That means that, say for example, if the current contents are, say ABC was already existing, we have entered it, say DEF. So file pointer will be here currently. To display the contents right from the first character, we have to move this file pointer from here to here. That we can do it using a function called as rewind. So rewind will take the control from this part to this part, the file pointer. Let us write the code. So rewind function using file pointer. Once we have rewinded the file pointer, now the file pointer is pointing it to the first character. Again, perform the same task here, what we have done using while loop. I'll copy this loop. This time I am displaying it to the user, reading it from the file. Now our last task is also done. Once we are done with this one, close the file using a file pointer and calling the function fclose. Now that we have already performed all our required tasks, let us build and check for any errors. You can see 0 errors and 0 warnings. That means it is perfect. Now you can see the message given by the user before appending the contents are, hello and welcome to files. Enter some text for appending. Let's enter some text over here. I have entered the text here in C language. This was the original contents of the files, and this is the newly appended text. You can see after appending hello and welcome to files in C language is the complete text of the file. Let us check this appended text is available in the file or not. Here is C colon new.txt. Here you can see the message hello and welcome to files in C language. This is the text what we have appended it. Let me just recollect the things what we have done. First thing is, we have opened an existing file in A+ mode such that whatever the text we are appending it, we have to read it again to display it. If file pointer is having null value, that means we are unable to open the file, give a message and terminate the program. Then display the contents to the user before appending, read the contents from the user what has to be appended. Then here is what we are appending it. Then take the file pointer to at the beginning of the first character and use a while loop to display the appended text. Hope this solution matches the program or the effort what you have done. That's all for now. We will see the remaining topics in the coming videos. Thank you. Hi, and welcome to another programming challenge. In this programming challenge, the task is copy the contents of one file into another file. Let us see the requirement. We must have at least one file to exist in the computer's memory. Let us assume that this file is source.txt. The contents, whatever is there in this particular file, has to be copied into another file, say target.txt. This file must exist. If this file is not existing also, we can create this file and copy the contents. So to read the data from this particular file and write it into this particular file, we must open this file in read mode and we must open this file in write mode. Take a file pointer, say source file pointer fp, target file pointer say ft. Using this file pointer, we can read the contents, and using this file pointer, we can write the contents into this particular file. Once we are done, then you can close both the files using this file pointers, and you can open this file again in read mode to display the contents to the user, whatever we have copied it. That is the task what we have to do it. So those who want to take this challenge can pause the video and pen down the logic, and those who want to continue, they can proceed. Let us start first by declaring the file pointers. File star fp, that is for source file, and ft, let us see these two pointers for two files. Open the first file, that is the source file, in read mode. Let us say target.txt is the target file. Once we have declared both the file pointers, check if any one of the file pointer returns a null value. Either the first file pointer or the second file pointer returns a null value. Give appropriate message to the user and terminate the program. Whenever we are using exit of 0, let us copy the contents. To copy the contents, we need a loop. Here I am using a while loop until the end of file of the first one, that is the source file. Read one character by calling getC function by using a parameter of the first file. Once we got the character over here, I need to declare this here, character ch. Then once I got the character in a variable ch, I can copy the contents using fprintf. Fprintf takes three parameters, that is the first one is the file pointer of the target one, and the format, character by character we are writing, then followed by the variable in which the character is there. Before printing the data into the file, we can display the data to the user as well. Same character ch. So I can give a message to the user that these are the contents of the source file. Once we have copied down character by character until the end of file of the first source file, we can close the file pointers of both source file as well as the target file. Now we need to open the target file and display the contents to the user once again. So here I'll copy this one, this is target one. I'll copy this. This time we will be opening in read mode and give the message to the user that these are the contents of the target file. To display the contents of the target file, we need a loop again. Similar loop what we have used over here. So what are the changes I have to do to this loop? Here the file pointer should be of target type, read one character and display the data. Need not copy the data here into the file, and the file pointer we have to change it because we have to read it from the target file. Same thing what we have done here, we are reading the contents from the source file, displaying the data to the user and writing the content character by character into the target file. In this while loop, once the file is open in read mode, we are reading character by character from target file and displaying the data to the user. And at the end, we need to close the file what we have just now opened for reading purpose. Wait for the user to enter. Let us build and check for any errors. Zero errors, zero warnings, perfectly. Let's run and check. Here you can see the contents of the source file. Here the contents of the source file is starting. We are using the same file what we have written the program, and here is the message contents of the target file. Same contents are copied now. Let us see the files, file copy.c and target.txt. Here is one file, file copy.c. Let's open it. Here are the contents what we got it as the output, and target.txt got the same contents. Let me repeat the concept what we have done. Here we need to copy the contents of one file into another one, so we require two file pointers. One file to be open in read mode, which is already existing. Another file in which we have to write, we are opening in W mode. If this file does not exist also, a new file will be created and the contents will be copied. Let us check first. Any one of the file pointer is null, give a message and terminate the program. Here is the actual logic. Until the end of file of the first file reaches, we are reading character using getC function in a variable ch and displaying the same character to the user and copying the contents into the target file. Here is the target file pointer character by character. Then close both the file pointers and again open the target file in read mode. And here we need to iterate the file pointer of the target file, read the character and display it to the user. And at the end of this while loop, when all the characters are displayed, close the file pointer of the target file. Hope the concept is clear. We will continue with the remaining topics in the coming videos. Thank you. Hi and welcome to another programming challenge. In this programming challenge, we have to find the number of characters, number of words and the number of sentences available in a specific file. So here the task is to count the number of character first, count the number of words next, as well as count the number of sentences. Let us have a file. Assume that we have a file with the following contents. To achieve this task, we will take three variables here. Say number of characters initialized to 0, number of words initialized to 0, as well as number of sentences initialized to 0. All these three are integer type of variables. We will take a file pointer. Within the loop, we will start iterating from the first character until the last file end of file pointer. Until it is not null, we are going to iterate it. Let us say we have encountered one space over here. Then this completes the first word. So number of words are now incremented by 1. But within this word, we have already came across 1, 2, 3, 4 and 5 characters. That means that whenever we are iterating one by one character, this value has to be incremented every time. Once we have encountered a space, number of words are incremented. And then here also we have encountered one more space, number of words are incremented. Even when we encounter a full stop as well as space, number of words has to be incremented. But as soon as we encountered a full stop over here, number of words anyhow has to be incremented by 1, but number of sentences also should be incremented by 1. Irrespective of number of words or number of sentences, we have to go on incrementing the number of characters. So here number of sentences are 1 completed here. Then this, after this we have again a space. Number of words are again incremented. After is again a space, number of words are again incremented, so on until the last full stop. Number of word is also again incremented by 1. But here number of sentences are 2. So we must display at the end how many number of characters we got it in this variable, how many number of words we got in this variable, and how many number of sentences we got it in this variable. We have to print it at the end of the program. So by taking this solution guidelines, I hope you can pen down the logic and write down the program. All the best for you, and those who want to see the solution, you can proceed with the video. Let us start with declaring a file pointer here. We require variables over here. Number of characters, simultaneously it has to initialize to 0. Number of words, which is also to be initialized to 0, as well as number of sentences, which should also be initialized to 0. Then immediately we will open the file here using fopen function. This file must be existing, should be open in read mode, because we just need to read the contents from the file. We need not write anything. And immediately you check if this file pointer returns a null value, that means that unable to open the file. Give a message and terminate the program. We required now. Once the file is successfully opened, we need to iterate it until we reach the end of file pointer. We will be using a loop over here, while loop. Let us have a character to be declared. So I'll be declaring one character variable over here, say character ch. That character variable we will be using it over here, that until that character what we are reading it from the file using fgetC function. fgetC function takes a file pointer as a parameter and returns a character until not equals to EOF, that is end of file. What we need to do here is check the character what we are getting from the file is a space. How do you check for space? Just give one space within single quotation mark. If it is so, then we will be incrementing number of words by 1. Let us say if we have encountered a dot, that means that number of words should be incremented by 1, as well as number of sentences should also be incremented by 1. Let it be any case, we have to increment the number of characters by 1, that we have seen in the logic. Once we are done with the complete end of file has reached, we got the result in number of characters, number of words, and number of sentences. Just display the data to the user. This is for number of characters. Similarly, we will do it for number of words as well as number of sentences. Once we are done with displaying the data, the only thing that is left out is at the end of the program we have to close the file pointer using fclose function. Now once we have done with this one, let us build, check for any errors. No errors, so let us proceed. Here is the output. The output of the program is the number of characters are 61, number of words are 10, number of sentences are 2. But what exactly the contents of the files are? We don't know what exactly the contents of the file. So let us first display the contents of the file here. Whenever we enter the loop, we got the character here. When we read the character, immediately display that character to the user using putchar function. So we are reading from the file, immediately displaying the data to the user. Then we are checking if it is a space, number of words are incremented. If it is dot, both number of words as well as sentences are incremented, and number of character anyhow has to be incremented for each and every character. Let it be space, let it be dot, or any other character. Let us now build and run the program here. So this putchar is now displaying character by character the contents from the file, and the number of characters are, you can count, the total number of characters are 61 and the total number of words are 10, and the number of sentences in this one, because of these two, one dot here, another dot here, gives you the answer as 2. Let us check the same contents from the file. Here is the test file and the contents are here. Hello and welcome. All the best for the programming challenge with 2 sentences and 61 characters. I hope this one satisfies the solution for this programming challenge. We will continue with the remaining topics in the coming videos. Thank you. Hi and welcome to another programming challenge. Let us see the problem statement here. We are given some employee data, or this data we have to read it and store it in one file, or the data is available in an employee file. Say for example, one file is available in which the data is there. Now, based on the IQ score of the employee, we have to categorize and store the data into 2 different files. Say these file names, let us say fail.c if IQ is less than 90, and if IQ is greater than or equals to 90, another file pass.c. So here, based on this particular one file, input file, or the data what we are going to read it over here. Say for example, this file contains name of the employee and the IQ score. If I have some test data, say for example A, B, C, D, E, some 5 records of employees are there whose IQ values are, let us say the IQ values are like this: 80, 95, 50, 90 and 89. If the value is less than 90, then this information we should store it in file say fail.c. So here you are going to have employee name A with 80, then again B 95. Since it is greater than or equals to 90, we will be placing it over here, B 95. Like that, we have to categorize the data into 2 different files. Now, by seeing this particular problem statement, I'll give you some solution guidelines so that you can proceed with the challenge to be solved. Now, with the given data, I'll provide some solution guidelines based on which you can solve the problem easily. Here, one file we required it, which contains the data to be read from the user. So we will be reading the data and storing the contents into this file. Then, based upon the IQ information, if it is less than 90, we have to create another file here and write the data into this one. Otherwise, write the data into this. Now, the modes in which we have to open the files. First of all, let's say if this file doesn't exist also, we have to create a new one. So we will be opening a file into W mode first. Then these 2 files should also be open in W mode because we have to write the contents into it. Once you have categorized the data separately into this file as well as this file, that is fail and pass file, then we will close these 2 files. Then again we will open the file into read mode. Read the data one by one and display the data to the user. Same thing over here. I suggest you to pause the video and continue with the program. Those who wants to see the program execution, they can continue the video. Now, the required variables we will be declaring it over here: file pointer, regular file pointer, and file pointer for one file called as fail, another file pointer for pass. So 3 file pointers we required. Next, we required the name of the employee. So I'll be taking A, the name of the employee, say maximum 20 size, and I'll be simultaneously declaring one more variable, say choice, to repeat the task using do while loop, and IQ score is of integer type. Now, sufficient amount of variables we have. Let us open the file first of all. say fp equals to, this statement opens the file test.c in write mode if the file exists already. If the file does not exist, it will create a new file and fp stores the address of that particular file. Let us say if fp takes null value, give appropriate message to the user and terminate the program. Since we are using exit of 0, stdlib is required. First thing what we will do before reading the data from the keyboard is we will give the column headings into the file by using fprintf function. What are those column headings are? Name of the employee as well as the IQ. So here we required a file pointer. First of all, using the file pointer, we are now going to write down, say, employee name. These contents are printed into the file using file pointer fp. Let us read the data using do while loop. Using scanf, we are going to read %s because it is an array, character array. Once we read the name, then read the score. IQ score is of integer type. Once we read both these contents, now let us write these contents into the file using fprintf. File pointer. Two things we have to write down. First thing is the name which is available in a character array, so it is %s, then two tabs in the file to be used, then %d, then the next contents we will print it into the next line. First one is A and second one is score. To continue, let's give the message to the user. If user wants to continue, once user sees this message, he will be entering some value. Read this value in some variable, say C. We have to declare this variable C here. Once we have read this information, now we have to continue this one using do while loop. Do while until the value of C is 1. We have to repeat this task because we are going to read one by one value and add the contents into the file. Once we are done with all the values to be entered into the file, then we will first close the file because the file is open in W mode. Once the file is closed, we will open the file now again in read mode. This message is printed to the user and read the content from the file using fscanf. Now read the data using while loop, while not file end of file of what? The file pointer fp. How long we have to continue? Until we reach the end of file. Let us read it here using fscanf, the file pointer first, then use the first delimiter operator, that is %s, because the first one name is the string and the second one is integer type, score, IQ score. Next line A and say score. Print the same contents to the user. Okay, this completes the while loop. Once you have printed the data to the user, again the same thing, f close the file pointer. Now this time we have to decide the contents of the files to be placed under pass file or fail file. For that one, again we will be opening the file. So I'll copy down here. File is again open in read mode. This time we open two more files. Pass file, let us say in C:, I am opening pass.c. In W mode, if it exists, it will open it, otherwise it will create and open a new file. Two files we have opened it. Read it from the main file, that is test file, using file pointer fp, and print it in both pass as well as the fail using pass file pointer and fail file pointer. Now once you have given the headings, this time we have to distribute the data according to the IQ score. This one we have to iterate it within a loop, not f end of file of the file pointer, original file pointer. Now you read it from main file, that is fp file pointer, %s for the first name, give some tabs, and %d for the next one, IQ, A that is storing the name, and score that is storing the IQ score. Here is the actual logic. Now if the score what we are reading it is supposed to be greater than or equals to say 90, then we call fprintf using pass file pointer and write the contents into it. Else, if the score is not greater than or equals to 90, then the same thing we will copy it here and write the contents into another file with a file pointer fail. Now this one has to be repeated within a loop. Once you are done with this, close all the file pointers. Now the last task that is left out is we have to open both pass file as well as fail file in read mode and read the contents and display it to the user. For that one, I'll be opening file pointers over here. This time we have to open it in read mode. Give a message to the user. The contents of the pass file are using fscanf read it. File pointer is pass and we have employee name. Now iterate it within a loop, what we have done earlier also. Read the data from the file and print it to the user. So I'll just use another while loop here, not of f end of file, using now this time pass file pointer. Two things we have to do it here. Read from the file called as pass using the delimiter operator %s. Once you read the data, print it to the user, that is display the message to the user. Close that file using file pointer pass. Repeat the same task for fail also. So I'll just copy down here. So we will be opening this time file fail. Now once you are done with closing the file fail, let us build and check for any errors. No errors, no warnings, perfect. Let us run the program and check the code. Here is the message what you are getting. Enter the name of the candidate. I'll be entering the name of the candidate, say some alphabets A. I'm entering it over here and the score is 95. I'll continue by entering 1 for the next data element, then the next IQ value, say 80, then 1 again to continue, then next name, then I'll enter it, say score 55, press 1 to continue, then again some D and say 99, and I want to continue, again I'll enter 1. So this time last record we will enter it and say 100. Now once you have entered 5 records or 5 or information of 5 candidates, I want to terminate this one by pressing any other value other than 1. Here first what we are getting is the contents of our actual file, that is test. We have entered 5 records with IQ value 95, 80, 55, 99 and 100. Based upon this one we got pass file containing IQ values. You can see this one is greater than or equals to 90, and we got fail information file here which is less than 90. It is categorized from here. So these are the two separate files we are having, pass and fail, extracted from test file. Let us see in the memory hard disk whether the same files are existing or not. This file, that is test.c first. Let's open it with notepad and check. We have entered the same records with employee name as the heading and IQ as the second heading, with employee names and IQ score. This is the first file. Keep this file as it is and I'll open the next file. Here we are having another file, and let us see this file also with fail information. Here you can see the main file, that is test.c, containing 5 records what we have entered, and based upon the IQ values, these are all the IQ values greater than or equals to 90, and these are all the IQ values less than 90, and this is file name is fail.c and this file name is pass.c. So these are the contents which are distributed in 2 files here. I hope this matches the solution what you have generated. So this one was another programming challenge using files. We will continue with the remaining topics in the coming videos. Thank you.